Welcome to the 6th edition of the Smart Objects and Technologies for Social Good Conference, GoodTechs. Originally, we planned to hold this conference in Antwerp, Belgium. But due to the Corona-19 pandemic, we embraced digital solutions. Well, after all, we are a community who proposes digital solutions to enhance a social improvement. So we should be the first one to embrace such digital solution and to hold a digital edition, a digital conference edition. Certainly, we strive for technological solutions to enhance our day-to-day life and our society in general. I am Johan Marquez Barja. I'm a professor at University of Antwerp and IMEC, the Research Center. And on behalf of the organizing committee and my colleague, Professor Katia Prandi, I want to welcome you to the conference, to the 2020 edition of our conference, GoodTechs. I want to thank you all for attending this virtual edition. And also I want to thank you for your commitment to research and to education. In the next 3 days, we will share our latest results regarding research, innovation, and education that aim to have a societal impact and aim to improve our society in general. Our technical program committee has elaborated an interesting offer to you, where different topics are carefully combined and planned, aiming to spark interactions among all of us, among the attendees, and to exchange our viewpoints. I want to thank the members of the TPC for their hard work. I want to thank Steven, Ombreta, Ademir, Juanita, Pietro, Silvia, Julio, Carlos, Hannah, Dima, Claudio, Joao, and Daniel for all their support to have this online edition today. As I mentioned before, initially we aimed for a traditional conference to be hosted in Antwerp. So there were a lot of efforts invested. We organized different events in order to enhance your experience of GoodTechs in Antwerp by not only having an amazing educational and research experience, but also a local experience enjoying Antwerp. But here we are today, sharing through this digital media system. Once again, I want to thank you for your commitment, to you all as attendees, and to share within this media. Let's get the best of these 3 days. Let's exchange opinions. Let's share our viewpoints. Let's build a future together. Last but not least, I want to thank IMEC, University of Antwerp, and ID Lab Research Group, which is a research group part of IMEC and University of Antwerp. They had offered us strong support in both organizations, the initial traditional conference in Antwerp and the digital one. Thanks for your support, for your help, and well, with no further delay, I want to give the floor to my colleague, Professor Katia Prandi, so she will tell you about the program, the interesting program that we have for you, the main topics that are going to be discussed during these 3 days, and how you can interact, and she will explain as well how we can interact and how we can use this media system. Thank you very much for everything, and see you around these three days. Cheers.
Thank you very much, Johan, and welcome to the GoodTechs conference also from my side. I'm Katia Prandi, Assistant Professor at the University of Bologna and General Co-Chair of this edition. In the next few minutes, I will provide you with some statistics that we all love to see and other detail about this very special edition of GoodTechs, including how this online edition will take place and the program. Starting with the GoodTech tracks, this year we have 8 tracks. The main track, as always, the work in progress and PhD tracks, to welcome short contribution and PhD research statement, and 6 special section tracks, selected after a strict review process based on the proposed topics and the interest of the GoodTechs community. The selected special session tracks are Smart Moving, Serious Game to Improve Quality of Life, OASIS, Open Challenge in Online Social Networks, Ambient Intelligent and Smart Environment, ICT, Enhanced Education with Social Impact, and Artificial Intelligence for People. Considering the submission, we received a total number of 97 papers, 76 full papers and 21 work-in-progress PhD student papers. The result is really good since despite the critical period we are experiencing, it is completely aligned with previous edition. Then, after rigorous review process, 52 papers has been accepted, 37 full paper and 15 work-in-progress and PhD student paper. I would like to highlight that we received high-quality papers that make really hard to keep an acceptance rate below 15%. Zooming into the number, in these slides it's possible to see the accepted number per tracks, with the main tracks that has attracted the higher number of papers as expected. Another interesting data to analyze is the one related to the author current University of Research Institute of the accepted paper. We can see that Italy confirmed to be the country with the higher number. But, as is well visible in this slide, as a second place we have Canada, a really interesting result. Moreover, new country and continent entering into the list, another great achievement for the GoodTechs community. Due to the pandemic, this year's conference will be fully online, streamed live on YouTube, as you should know by now. Moreover, a Slack channel has been created to collect questions, comments, and discussion between author and the GoodTechs community, and will be active as a live chat for the 3 days of the conference. I would like to remember that the conference can be freely attended by everyone. This year we have the pleasure to have 3 keynote speakers, and for the first time we will have a workshop. You can find the detailed program on the GoodTechs website. Here a brief overview of the 3-day conference schedule. Please check the GoodTechs website for further detail. Important is to notice that tomorrow, after the afternoon sessions, we will announce the GoodTechs Awards, so stay tuned. As a final remark, please be aware that all the time slots are approximated, since they strongly depend on the duration of the auto-recorded video. As I anticipated you, we will have amazing keynote speaker. Today we will start with Professor Nunes from Technical University of Lisbon, with his inspiring talk about eco-centric interaction considering the intriguing relationship between human and nature. And tomorrow we will continue with Professor Levian de Mares from Ghent University and his talk about empowering users and domesticating technologies. During the last day, we will have another keynote speaker, Luis Carrascal Crespo, who will present a data protection toolkit to reduce risk in hospital and care center as part of the Data Protection for Healthcare workshop organized by the Protego project. This workshop will run in the afternoon of the third and last day of the conference with interesting invited talk. Also in this case, everyone can freely attend. That's all for now. Thank you very much for your attention, and I really hope you will enjoy this online edition of the GoodTechs conference. Bye!
Dear ladies and gentlemen, let me welcome you to EAI GoodTechs 2020 conference held in this virtual interactive setting. I am Karolina Marcinova, the EAI conference manager of GoodTechs 2020. Unfortunately, I am not able to meet all of you in person, so I'm using this opportunity to address everyone on behalf of EAI. I would like to thank all of you for being a part of this conference and for your involvement with EAI. I would also like to thank the General Chair Katia Prandi and Johan Marquez Barria, together with the whole organizing committee, for their hard and excellent work throughout the whole process of the conference preparation. Today, during this streaming, you can actively participate in 2 ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing EAI GoodTechs 2020 Slack workspace, you can enter all the channels, which are divided by sessions. Secondly, you can vote on individual presentations and leave your fellow presenters feedback on their work through EAI Compass. We will shortly show you how to access this platform and how to leave and receive feedback for presentations in this conference. I would also like to use this message to invite you to join us again at EAI GoodTechs 2021, which will take place in Aveiro, Portugal in September 2021. Should you be interested in becoming a part of next year's organizing committee or the technical program committee, please do not hesitate to contact me at my email address below. If you are interested in discussing other possible cooperation, a conference, a workshop, or a new event altogether, please contact me at my email address as well. Now my colleague Michal will present you with what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy EAI GoodTechs 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello, my name is Nunes. I'm a professor at the University of Lisbon at the engineering school called Técnico, and the president of the Interaction Technologies Institute, and also co-director of the Carnegie Mellon Portugal program international partnership. And it's my pleasure to give you this keynote for GoodTech in such weird conditions that we've been experiencing the last months with the COVID, and giving it recording and giving it virtually. A little bit of the background. ITI was founded 10 years ago as the first and still the only HCI institute in Portugal, which is started in the University of Madeira in an autonomous region of Portugal, and then moved into Lisbon and is affiliated with these three institutions, the University of Madeira Engineering School and the Fine Arts Schools of the University of Lisbon. We're also part of a bigger lab at the national level called LARSES, the Robotics and Systems Engineering research lab in Portugal. The vision of ITI when it was born in Madeira, an outermost region of Europe in the Atlantic, was that we could be a connection between the southern hemisphere countries that Portuguese speaking, like Brazil and the African countries, and also the connections that we had with the US, with the top institutions through the international partnerships that Portugal had created, and also many of our partners in Europe. And this idea that because we are situated there, because Madeira is an outermost region of Europe, because Lisbon is the only Atlantic capital in Europe, we could really play a role in understanding how computing could be used to solve many of these very pressing problems that we have, like climate change and biodiversity crisis, and many other issues that we are witnessing in these turbulent times. And so our research has been evolving with computing technology. Initially, it was much more focused on engineering. Right now, since 20 years ago, when computing became good enough, we started looking at more at the marketing and service perspectives, and now currently in design, because as technology got good enough, it's more important to understand what we can do with technology and less how we improve the technology itself. This is an example of this type of perspective, where one of our colleagues from ITI, James Odger, developed this device that is connected with AI and shows how a family is in sync or not, anticipating a problem, a family discussion, an argument between a couple, between a family when something is not going well. So that's an example of what we can do. And what I'm going to talk today is much more about my own research, which is trying to understand how we can use computing technology to engage people with a more kind of natural environment, and to try to reconnect people with the non-human actors that we have, and especially coming from Madeira, I was born in Madeira. You have a very different perspective of what computing could do when you are in the middle of the ocean, surrounded by a lot of biodiversity in the ocean, and you kind of reimagine how computing could happen. And if we look back to computing, in the beginning with the mainframe, there were a lot of people, interacting with a big system. Then we came in the late 70s, beginning of the 80s with the personal computing era. We had one person working one computer, and the canonical device was like the PC, and the kind of killer application was the spreadsheet. And then we moved on to Ubicomp computing, where you had one person with multiple devices, and again the application was a lot of these personal calendars and management systems. And then we moved on into many people, many devices, and we are currently in this area where we're not sure where things are going to go. But what we do know is that people are using their devices to do many things, and especially to take photos of themselves, selfies, and posting them on social media, and that's not necessarily the best use of computing technology for our future. And so because we do have a lot of connections with other areas, I always show this example. Nunes is literal bishop anticipated new uses of technology, in this special case the idea of tangible computing.
1 p.m. Hi Simon, it's about 1 o'clock now. I was wondering whether you're going to come to the football. It's the weather's a bit wet and rainy, so I understand if you don't. Other than that, well, yeah, give us a ring if you're in. Okay, bye.
Messages immediately deleted, and then if you want to pass
3:45 p.m.
Hi Emma, it's Val.
on the respective
3:30.
placeholder. So design and art have always had an important role in defining the future of computing, and that's something that I'm really interested in. Of course, we are driven by economics, and we've seen also how computing kind of affected the evolution of what is called the experience economy, where we moved from extracting commodities to making products, delivering services, and now staging experiences. And this kind of, the reason why I'm showing this slide is because this had a profound impact in the role of also again of design in computing, because when you're trying to stage experiences, you need a completely different skill set than you had when you were making products or even delivering services. So the idea that you are dealing with much more complex ecosystem of technology, people, processes, businesses, business models, and how computing has actually changed completely business models, and how you can actually go up in the ladder of the experience economy, from selling a commodity like beans, which are less than a cent per cup, to selling a marketing product in the supermarket, or a coffee in a good coffee shop like in Portugal or in Italy, or even just selling an experience in Starbucks, even if the coffee many times sucks. I'm not a big fan. And then when you enter what's happening right now in the last 10 years, when the big tech companies became the most important companies in the world, and data is becoming the fuel of our economy, these things change profoundly the way our societies and our economies work, and we need to reflect on that in order to be able to build a better world. So let me give you one example of how these things connect. And the example I'm going to give you about is using Apple as the example. This is the cycle of experience from Hugh Dubberly and Shelley Evanson, where you have these stages where you connect and attract, the orient, the interact, the extend and retain, and the advocate. And these different phases, through an example, show how, for instance, Apple is always very good at connecting and attracting their customers. They always launch new products, new services, and they create a buzz in the media. They hire bloggers, influencers, so that they can create a buzz about what's going to happen. Usually we are now reaching September. Usually in September there is a big event and everybody's talking about that. So the Connect and Attract is very important. This is actually the ad from the 2011 product launch, which was the iPad. That is now, the tablet is now the most sold personal computing device. Then the Orient, the branding is very important. Apple is no longer Apple Computer, it's Apple. You can clearly identify the branding and the shops, and the Orient people inside the shops. It was one of the first shops that had no counter, so you can actually approach someone and you pay for whatever you're paying. Then of course there is the interaction, which is the important component for a while was how you interact with these devices. A lot of research is done on these topics, but it's just a small component of the whole cycle of interaction. And there is obviously the extend and retain. There's a lot of discussion going on about how Apple and Google, through their stores, kind of became a monopoly and they are controlling the market. And actually this is how Apple was able to supersede the Nokias of the time when they created the iPhone. And finally the Advocate. This is an interesting photo showing a lot of people having the logo of the Apple on the back of the computers. And so Apple, more than becoming or being a very good engineering company, what it was able to understand was not just the interaction was important, but it was the whole cycle of interaction that was important. And if you see some of the recent keynotes from the CEO of Apple, you will see that they are looking at services as a key component together with hardware and software. And that's, again, a very important element to take into consideration when we are looking at good examples like the example of Apple. And so this is just a brief introduction of what I think is relevant, and then what kind of intrigued me in the last 10-15 years when I started moving out from my research, which was more on formal systems and software engineering and HEI, into kind of trying to understand what I could do to help a better world. And this is why I also think that you have a great conference with Good Tech is a very good topic for what we should be doing now. And so the idea is that, if you look at, for instance, energy as an important area that could have a profound impact in the future of our world, and you can see that energy is still pretty much sold as a commodity, and there was not a lot of evolution in how you could make energy as a sector evolve and use computing to do that. So now of course you have energy as a product. You can buy batteries in the supermarket. You can even, there's a lot of discussion about how you could use batteries to create a new kind of more sustainable future for energy. You can even sell energy as a service. You can recharge electric vehicles. You could, some companies are starting to sell, instead of selling energy as kilowatt hour, they are starting to sell a building at 20 degrees Celsius. So instead of selling energy, and then you buy the equipment, you plug in the equipment consume the energy, you're actually selling everything as a service. And then I started imagining what can you do as energy as an experience. Of course, electric shock therapy is one probably not very good example of how you could use energy as an experience, but it is something that it kind of makes you think about how such an important area and field has not been evolving that much into the experience economy. So that's part of the research I've done with some of my PhD students, Lucas Pereira, Filipe Quintal, Mary Barreto, Sabrina Scuri, Valentina Nisi. And so we started, again, I'm an engineer, we started looking at how we could use sensors to increase the amount of information we have about energy consumption in the home. We started with the home. So you could use these sensors. These sensors will detect when someone switches on or off an equipment, and then by learning, using machine learning, you could disaggregate the energy. And immediately we bumped into a problem, is that, okay, we could do that, it's feasible, it needs to be trained, and then you need to ask people to train so that the system can learn the devices in your home, and that's not necessarily a good thing, because people have better things to do with their life. And then we installed these things in the houses, and we were measuring if people were looking at their consumption, and we found out that after 3 weeks, in a systematic way, people were looking at other things. Why? Mostly because people have better things to do with their lives. They have their kids, they're coming home after work, they are tired, they just want to relax, they don't want to train the system that knows how to detect the devices. And so we started experimenting with this computing technology to try to do some research on eco-feedback. There are tons of papers that we published on this. One of these, as you can see, is what I see, is where we're trying to make energy a more tangible thing. So we could can we show when is the best time for you to plug in your device? And so we created a few visualizations. We also created this new plug which will change color depending on how much renewable energy you had in your home, so you could have a kind of a hint of when you should be using your energy or not. And then we even, coming back to the topic of biodiversity and nature, we started experimenting with ways of providing feedback. Like in Madeira, there is this phenomena where you can have movement of the clouds. So we started trying to map the energy consumption to the movement of the clouds. We even experimented with mapping energy consumption in devices to animals and plants. It was not necessarily worked that well. And then in another paper called What's Burning on My Mailbox, we even mapped the landscape. Madeira is a Laurisilva forest, which is a natural heritage, and we tried to map the energy consumption to the long-term effects of climate change, which are, for instance, fires and extreme events. Unfortunately, our research was kind of preceded some of the fires that happened in Madeira 3 or 4 years ago, which was devastating. And then in the mainland, we had a similar effect. And from then on, we moved on into trying to understand how we could use blockchain technology to mediate the exchanges of energy between a small neighborhood, and to understand how, by using this technology, people would actually interact with their energy consumption. And we found out that people actually care more about their neighbors, and they are actually willing to give away their energy to their neighbors, because that is a good way, to get to know your neighbor. And so there is the human component, which can and should be used in order to provide a more successful technology for microgrid scenarios and more sustainable energy futures. And this is ongoing work. We had a big European project, and there's a lot of, if you're interested, there is a lot of work that we've published on the energy sector. Another area that we explored is tourism, because again, Madeira, where we were working back then, has a huge, it depends a lot on tourism, like many Southern European countries, and we are seeing now the consequences of that with the COVID crisis. And tourism is an economic sector that depends on mobility as a form of capital, so that's why it's so impacted by COVID. And in this project, Madeira is a beautiful place, so we started by looking at what was happening, but also by looking at what should not happen. Like, you have a lot of these things happening right now. Unfortunately, because of the COVID crisis, people are trying to avoid going to these crowded places, but it was happening, and it will go back. Even if we try to not to go back to the same normal, you will see queues of people trying to look at the best points of interest. Even in the Everest, some people died recently because they were queuing to get to the top of the peak. And the idea was that, could we, in a small island which has an interesting landscape and has an interesting number of people living there, 270,000. It's the third metropolitan area in Portugal. And can we use this area, which is relatively small, to try to understand the movement of people in relationship to tourism? So we identified these points of interest in the island, and of course also in the capital, Funchal. We installed some devices to sense the presence of people through Wi-Fi signals, which ensure privacy because you cannot detect the devices, but at the same time give a good proxy of the presence of people. And we've developed many visualizations of this information that again were published in some of the papers that you, if you're interested, you can Google. We then moved on to try and visualize this information for the general public. Do people in the island understand the impact of tourism? And this is one of the visualizations that shows the incoming traffic of planes and cruise ships and how people were moving. And by the way, we adapted this infrastructure for the new COVID crisis, and it's actually working right now and used as a way to give people feedback about the most busy places in the island during the COVID situation. So we are here is showing the visualization of the number of people since the COVID happened, and then you can check at what times of the day you should go there. And we even created some widgets where you can show in real time the pressure of the place depending on the time of the day. And so you can give real-time feedback to people that are moving through the island, and hopefully this information will help them avoid the crowded spaces during the pandemic, but also in the long term to avoid crowded spaces because we want to have more sustainable tourism in the island. One thing that we learned from this research is that it's relatively easy to gather quantitative data. So you can install these sensors. Of course, Madeira is a good living lab, and it's relatively small, so you can talk to the authorities and you get collaboration from these authorities. You can do this. We had several H2020 projects where we could deploy this technology. But many times we were not sure of what the quantitative information was telling us about the place. And so this is one of the reasons why we worked with the group from Yvonne Rogers, with Stephen Huben and Ben Bangler, and we installed these tangible devices to learn more about the quantitative data, so to give qualitative insights on top of the quantitative data. And so we learned some things with this research, and we were able to create what we called hybrid data sets. So data sets that mix the quantitative information about how many people there are in a particular place with how people feel. And we are evolving this research direction in the COVID situation by creating ubiquitous analytics devices where you can actually annotate the data and say, okay, this place doesn't look busy, but I feel that it's not very safe for whatever reason. Or on the other hand, this place seems to be busy, but actually I feel quite safe because everybody's wearing a mask, or because the space is quite comfortable for this number of people. And moving on, another project, this was a student project called Be Eco, and it's an interesting example that I always like to show, because this was one of the first projects where we actually started engaging with the local biologists and the marine reserve park, and that's something that influenced a lot the research. And this project was about how could we use the interactive technologies to increase the awareness about the endangered species and the natural reserve parks in Madeira. 2/3 of the island are a natural reserve park. And the students came up with this idea. First, they learned that it's very hard to create this relationship, because the ones that are causing more impact in the natural reserve park are actually the people that depend on the park for their well-being, the fishermen and the farmers especially. And these people are not very keen on talking and discussing with the local authorities, because they feel that these local authorities are going to prevent their economic activities. And so the students created this game called Be Eco, where they went on...
The mission of the Eco-Compatible Life Project is to convince people to make small changes in their behavior, to live in harmony with nature, while also benefiting the local economy and themselves.
By doing that,
the natural park was formed to protect the rich natural heritage of Madeira, but the forest and marine reserves have suffered the effects of human activity. But why should people change? How can we get them to care?
Motivation to watch the game and to understand the game, because they knew that their kids had drawn part of the game.
Any attempt to change someone's behavior should focus on relationships. For most, family has the strongest effect of behavior, and children connect us with our future. They provide emotional experiences that capture our attention and stay in our memory. Creating heartfelt connections also creates future stakeholders, those that will continue to share the message. So we engaged children from local communities to draw the nature around them and how they felt about what was happening to it. We incorporated the images from their stories into a collaborative visual design in order to engage farmers and fishermen and begin a relationship with them and their children as future stakeholders.
And it's beautifully designed.
Be Eco is a learning experience to inform farmers and fishermen how to live an eco-compatible life. It shows them small changes they can make to live.
It was showing how we could use technology in a smart way to actually try to change people's behavior in a way that is sustainable and makes them reflect about the future. From then on, we started thinking about the other problems where you would need to sense what's happening around you. Some of the inspiration comes from this wonderful book called Darwin Comes to Town, where Menos Fitzgerald is kind of arguing that because a lot of the population is actually moving into cities became more biodiverse than actually the countryside. Because of agriculture, most of the countryside is completely zeroed out in terms of biodiversity. It's very monotonous. You have these cultures. So you've killed a lot of the biodiversity in the countryside. So the cities, together with some very particular places, and again, Madeira and the outermost regions of Europe hold 80% of the biodiversity of Europe. So you can imagine how precious these islands are in terms of retaining the heritage, the biodiversity heritage of the planet. And by looking at these examples and looking at what was happening around me, I came up with this idea together with Dinarta Vasconcelos, a PhD student, and also Katia Prandi, Alex Rogers from Oxford, and other students from Técnico in Lisbon. How can we use these ecoacoustic devices to try and detect animals? The first attempt was actually with mosquitoes, because again, Madeira was one of the first places in Europe, or the first place in Europe that had the Aedes aegyptus, which is this species of mosquito that is a vector for many diseases, including dengue and Zika. And in front of my home, we had this bucket, and this bucket is actually the manual trap used by the authorities to measure the presence of the mosquitoes. And they were very successful in controlling the outbreak of dengue, and now it's gone for more than 15 years. But they still monitor, and I was thinking, this is not an easy thing to do. So can we do something with technology that is going to make the monitoring of these mosquitoes, which are, by the way, the most endangered, the most dangerous animal in the world that kills more people is the mosquito. Can we do something about it? And the idea came of using these devices where you could record the sound of the wing flap of the mosquito and try to identify the mosquito species and count the number of mosquitoes using that. It's ongoing work. It's actually been tested now also in Thailand, and in many other places where they have problems, much more severe problems with mosquitoes. But it's a good example of how you can use technology to monitor biodiversity. And then, of course, what do you do with this information? It's very sensitive information. People want to know if the mosquitoes are there, but at the same time, if it's a touristic island, it's not necessarily a nice thing to go and advertise, be careful about the mosquitoes. So we created this game, and we are experimenting with a lot of these ideas about, can we create a game that actually uses the data from the mosquitoes, gamifies that information, and makes it into a more engaging experiences for people. And this master project from Loureiro is about trying to create a game where you actually build these strange animals with the data from the mosquitoes. And from mosquitoes, using more or less the same technology, we started looking at whales. Whales are a mythological animal. They've been hunted and almost to extinction in the last 200 years. And now they've been recovering. Recent research shows actually that if we are able to recover the population of whales to pre-whaling, we will be able to solve a lot of the problems with CO2 emissions, because these animals, they are able to store and to capture a lot of CO2 emissions because they become huge animals, and when they die they sink, so the carbon goes into the bottom of the sea, and it's a very effective way of capturing CO2. And so we came up with this idea called Poseidon. Can we use the same passive acoustic ocean sensor and use it to enhance whale watching? And again, like I was telling, whale watching started from whaling. It then became, before extinction, it became actually the animals became, with Free Willy, became one of the most iconic examples of and Greenpeace of this new environmentalism movement. And now they are coming again. We are trying to reconnect with whales. Whale watching is becoming a very important ecotouristic activity, to the point that now even the marine biologists are worried that this might actually harm the animals. The amount of people are trying to see the whales. And nevertheless, you can see here again the same type of progression that I was talking about in the beginning with the experience economy. Extract commodities by using whales and the oil of the whales as an energy source. Then you move into whaling, using whales and products from the whales to create products. Then, fortunately, whaling is forbidden, and then you start looking at whales as services and experiences, and that's where the stage we are. And again, can we use technology to enhance this experience and actually even to make people a little bit more far away from the whales, so that the whale watching experience becomes more interesting? And that's part of the research that we have been conducting together with Marco Jardeta, Valentin Inisi, and many other colleagues at ITI. So the idea that you can put a buoy, and this buoy has an hydrophone that captures the sound of the whales, and then you can listen to the sound, and you can use the sound to enhance the whale watching experience. This is then actually the deployment of the technology, and you can even do some citizen science. So you can classify the whales, you can help the marine biologists understand what's happening. And by the way, people love the experience, listening to the whales, and not just being there and trying to do the selfie with the whale, which is a kind of a very boring thing. So part of this research is going into trying to use the technologies that are mostly being used to inside of densely urban spaces, like Internet of Things technologies, like long range LoRa kind of network, and trying to use it to kind of connect to the surrounding environment, like the oceans and the biodiversity around you. So that's part of the research that I'm doing. So if you are interested in this, please contact me. I'm looking for PhD students. This is a photo of actually Marco, who has been the champion of deploying some of these technologies. And the project that we have right now is actually looking at ways of using small sensing devices in the animals, and using the animals to help us learn more about what's happening at a larger scale. This is a mapping that I was completely surprised when I talked to the biologists and they showed me this. This is a mapping of that you can see of all of the migration paths of many of the animals that pass through Madeira, from the turtles that go all the way to the Gulf of Mexico, from the whales that go all the way to the Arctic, from some seabirds that go even to the Indian Ocean, and to Argentina. So if we could put some sensors in some of these animals, we could learn a lot about what's happening to them, what's happening to the global environment, and we hopefully could reconnect with the large-scale impact of our of humanity in spaces like the whole Atlantic, and that's what interests me now. And so I hope that with some of these examples, I could hopefully inspire you to do some good tech. Try to use your skills, your knowledge, your technology to actually try to solve some important problems. Many of the technology I've seen are being used by shopping malls to orient people inside shops. I mean, there is a lot of money in there, but do you really need that? And I hope that now with the COVID crisis, people kind of can reflect a little bit better on what they should be doing, what type of research they should be doing. And like Alan Kay was saying, the best way to predict the future is to invent it. And so these projects are here mapped in what I call eco-centric computing or eco-centric design. This idea that you can move from indoor scale authored content with small projects into large scale planet-wide live data deployments. And that's the hard kind of movement of some of the projects that I've tried to show you here. So when you're trying to apply technologies to detect mosquitoes, you could have a big impact in the planet. But by doing that, you need to solve many, many more demanding and interesting problems also in terms of research. And so the idea is that this fifth generation is going to be not just many devices to many people, but many devices to many people, many humans and many non-humans. So the idea that we should be trying to understand with this technology what's happening around us, not just necessarily with us. So the idea is that instead of having as a canonical application the selfie and the social network, we could have something that tells me what's happening around me, how are my actions impacting the environment, how is my community destroying the planet, and what can I do in order to improve that. So this is the vision, ongoing vision, is something that we are forming, that we've been writing about, and we are trying to disseminate and to try to recruit very good researchers, young people that are inspired by this vision of ecological well-being, and trying to see if they could use computing to do that. And so the idea is that we could, instead of just focusing on AI and being worried about what is going to AI to do, I think before AI takes over, before we are destroyed by this machine, I think we should worry about what we will be doing to destroy ourselves.
Just what do you think you're doing, Dave?
And going back to design and design fiction, there are a lot of futures, and you can design the future. You can influence the future by focusing your own research in problems that could actually make a difference, instead of thinking about how you can be rich by doing another company that doesn't necessarily do something good for humanity. And there are many different futures. We are actually seeing some not very plausible, interesting future right now with what's happening with this COVID crisis. And I think this should again be a moment for us to reflect and to think about what we do. And going back to the example of AI, I think in robotics, I think we are still haunted by this vision of Metropolis and the movie by Fritz Lang in the early 1919s, in 1927. But we should always take into consideration, this is one of my favorite movies, the Blade Runner from Ridley Scott, that even artists, even movies can take the future wrong. And that's one of my favorite examples, is that this machine that is so perfect, that is indistinguishable from a human, when it tries to connect to another machine that is so perfect and so indistinguishable from a human, it goes to a phone booth to make a phone call. And this is why, because Ridley Scott and the book that inspired the movie, they were not anticipating the personal device and the personal computer, the smartphone. And so I would like to close with the idea of design thinking instead of design thinking, as the social materiality collective of humans and non-humans that are replacing the object with thinking to put focus on experimenting, prototyping, infrastructure, and traveling. So this broader idea that you could actually use the technology to influence a different future, to design with these things, and to try to put computing into things, but to put it in a perspective that is much more sustainable and much more interesting. And one of my favorite examples of that is the work of this artist, Thomas Libertini, where he actually creates sculptures with bees. So it's a very good example of how we could cooperate with the animals around us. It is a fact that we have influenced the planet to an extent that it's impossible to go back. But at least going forward, perhaps we could try and be a little bit more cooperative and find inspiration in the non-humans around us to build a better future. And that's what I had to say. Thank you very much. You have my contacts here. You can find many of the papers and projects in my website or in the ITI larsis.pt website. Feel free to contact me, especially if you are interested in these topics and if you need some additional information. If you're interested in doing a PhD, we have some good opportunities together with Carnegie Mellon and the International Partnership. So please do reach out and make this more than just a kind of a remote keynote. Thank you very much.
Good morning, my name is Sara Komai, and in this talk I'm going to present a new solution to monitor cooker activities. The solution has been proposed by our research group on assistive technology at Politecnico di Milano, together with Eva Baffaro, Deborah Di Bartolo, Andrea Masciadri, and Fabio Salice. All the reports in the last years are showing the rapid increase of our aging society. By 2050, 1 in 6 people in the world will be over the age of 65, up from 1 in 11 in 2019. This is a global phenomenon. In all the continents, the median age is increasing, with high numbers in Europe and America, and with a fast-growing rate in the other parts of the world. This process of demographic aging is for sure a success in the history of humanity, but poses new challenges. In fact, the ratio between the number of older people relative to the size of the working age population will continue to rise. This is called the old age dependency ratio. So the part of the population that is potentially available to take care of the older generations is decreasing. There is therefore the need for solutions that support the well-being and the health care of the elderly. In the last 10 years, our research has been devoted to solutions that can promote the autonomous and independent life of older people, especially when they live at home alone. The goal of our ongoing research is to provide solutions that detect possible anomalies in the behavior of the older person and, in case of need, alert the caregiver. Such solutions allow to improve the quality of life of both the elderly and the caregiver. The former knows that in case of danger, the caregiver is notified. The latter is aware of the current status of the older person living alone. Most of our solutions aim at letting elderly people live safely and comfortably at home as long as possible. In many cases, the cognitive decline is unavoidable, and it is important to monitor daily activities to ensure their safety in the domestic environment. If we consider the possible accidents that may occur at home, most of them occur in the kitchen, and in particular are related to the cooking activity. Leaving the equipment unattended or leaving heat sources too close to the cooker are among the main causes of fires or deaths at home. The danger increases as the age increases and is quite high for people aged over 75, since vision and hearing loss and mobility impairments exacerbate the risks. The most common solution adopted in the kitchen is the smoke detector. It measures the percentage of carbon dioxide. It decreases the risk, but it can only alert people of danger when the situation is almost critical. That is, when something is already burning enough to produce smoke. Besides, these kinds of systems produce several false alarms. For this reason, several alternative solutions have been proposed in the literature, using different kinds of sensors, like metal oxide sensors or thermal cameras. These sensors allow to detect fire, but again, they provide an alert when it is already too late. Moreover, cameras are considered too intrusive. Some help arrives also from smart plugs that are connected with the power source of the cooker and can send notifications about the state of the stove that can be on or off, so that prolonged usage of the cooker can be detected. Such plugs can be integrated into smart kitchens and together with smart appliances can support the monitoring of the cooking activity. However, smart kitchens are expensive solutions. The solution we propose is also based on the usage of sensors to monitor daily cooking activities, but the idea is to use low-cost sensors to detect unusual behaviors in the use of the cooker, to alert if a dangerous situation is taking place. With our solution, besides controlling the state of the cooker, we try also to understand if a person is in its proximity to detect unusual situations. For example, we are interested in checking if the stove has been left unattended. The status of the cooker is controlled using a grid-eye infrared array sensor, which is a grid of 8x8 sensors that measure the absolute temperatures detected by infrared radiation. In output, it provides the thermal presence, the direction, and the measured temperature values. It can be therefore used to detect the cooker temperatures, and in particular if the burner is on or off, and to monitor if an unsafe temperature has been reached. The presence of persons is detected using a sharp distance measuring sensor that can detect obstacles in the range of 20 to 80 centimeters of distance. Combining these two types of data, we can understand the person's cooking habits and identify if there is an unsupervised pot on the stove. A Raspberry Pi is used to collect all the data. These sensors are low cost, non-intrusive, low power consuming, and easy to integrate. Several experiments have been carried out to identify the best positions for the sensors. In particular, the best position for the grid eye is on top of the cooker, encapsulated in a transparent box to protect it. Since the grid eye has a fixed angle of reading, which is 60 degrees, the covered area depends on the height of its position. With a height of 60 centimeters, an area of approximately 70 by 70 centimeters can be covered. The sharp sensors has been attached to an edge of the furniture in a way that it detects the presence of people but is not affected by the heat of the stove. Being its signal analogic, an analog to digital converter is used. Both the grid eye and sharp sensors communicate with the Raspberry Pi through the I2C serial communication bus. Here, a Python script sends the data via Wi-Fi to a separate laptop, where data are analyzed with a MATLAB script. Some preprocessing on the collected data is applied. In the figure, the raw data are represented by the blue line. These data need to be filtered to limit the presence of outliers, typically due to noisy measurements. Different filters were evaluated, and running multiple experiments with ground truth annotation, the Gaussian filter has been selected. This is represented by the red line. It represents well the original data, but it removes all the outliers. The algorithm to analyze data is based on the control of both absolute temperature values and temperature's derivative values. By checking also the presence of persons, these data allow to classify the state of each burner with one of the following labels: on, on and heating up, on but cooling down, off and still cooling down, simply off, or potentially uncovered. That can be due to the situation where no pot is on the stove or there is an empty pot with the burner on. Or finally, there is the case of unattended cooking. The system requires some configuration. In particular, the correspondence between gas hobs and the sensor cells must be initially tuned. During configuration, also some thresholds are set, such as the positive and negative values of derivatives, to understand if the hob is heating up or cooling down, the ambient temperature, the temperature that is considered as a danger, and the maximum amount of time the person can stay away from the cooker before sending an alert. This figure shows a heat map representation of what we can obtain with the grid eye sensor when there are two pots with boiling water. Here we show the heat map representations of other possible states of the stove. In particular, the top left heat map represents a working stove with one gas hob on. On the top right, two flames are switched on. On bottom left, 3 gas hobs are on. And finally, on bottom right, all 4 flames are on. When a single hob is switched on, our algorithm obtains an accuracy of 89%. When the biggest gas hob is turned on, instead it affects a large area of the heat map due to the high heat dispersion. In this case, we obtain an accuracy of 76%, since it is not always possible to understand if only that hob is on or if also the smaller gas hobs are on. As far as data sampling is concerned, initially we sampled data at intervals of 1 second. Then the sampling time was increased to 2 seconds, since data were still accurate. It is also possible to improve the images and in particular to increase their resolution. The idea is to put close sensors that register similar data and to make a data fusion of the information to obtain higher resolution grids. With better images, also the results can improve. The main advantages of the proposed solutions are its low cost, the good performance that can be obtained, and moreover, through duplication of the grid eye sensors, we can improve their reliability and we can also increase the fault tolerance. On the other hand, the main disadvantages are related to environment where the sensor is installed, because in the kitchen, dirt with greasy vapors can be generated, and there can also be problems of humidity and insulation. Even the installation could be problematic, because in the solution adopted, the wires were used, and the positioning in the hood is delicate. To conclude, in this work we have proposed a system to monitor kitchen activities using some low-cost sensors. The applied algorithm is simple, but can detect the different states of the cooker and the status of unattended pot on this gas hob with a good accuracy. This allows to recognize some cooking activities and to monitor the person's health, for example, by checking that the person is regularly cooking. As future work, we plan to improve the accuracy of the results, by applying machine learning algorithms or neural networks, and to reduce the amount of data to be sent for the analysis by adding a pre-processing step directly on the Raspberry Pi. We hope you enjoyed the presentation, and we thank you for your attention.
Hello, dear ladies and gentlemen. My name is Irina Deva, and today I would like to introduce you our project, which is called Bayesian Networks-based Personal Data Synthesis. So, the task of generating personal synthetic data is quite actual and relevant, since synthetic data can be used in many areas. For example, in anonymization of personal data, or for example, when we don't have enough original data because of some problems, we can enrich our data by using some synthetic data. Also, it's about creation of the target group's data, because the creation of such kind of data can be expensive sometimes. And it's also about generation of community data with certain behavioral characteristics. So, and as we can see, in many problems, both the generation of personal data of one person and the modeling of entire synthetic communities are of interest. But when we develop such generation models, we first face with two problems. First of all, it's the lack of ready-made solutions for modeling several aspects of the human personality at once on data with different nature. Because the existing solutions, they usually use the nature of one the data of one nature, like social media data and so on, and they usually model some certain aspects of human for some certain tasks, like for anonymization tasks. But we need to create the complex model that can explain or describe the complexity of a person. And the second problem, it's the increasing complexity of the developed model when we add new data about a person. Modeling of many aspects of human behavior at the level of personality and society is quite difficult due to the significant multi-scale effect of the processes. And for example, the person can be described by some biological aspects, and these biological aspects can be connected with some psychological and other sides of a person. That's why we're speaking about the multi-scale model of a person. And at the same time, the data about a person can be changed quite often, like every day. And in this case, we're speaking about the dynamic model. So, getting back to the task of creating the generative model for synthetic data production, we meet the problem concerning the necessity of learning the whole model each time we obtain the new data. To avoid this complexity, these additional expenses for relearning our model, in this case it's Bayesian network, we offer the method of hierarchical block learning. It means that the fully connected Bayesian network can be divided into some partial networks which describe some layer or some side of a person. And all these partial networks can be connected via the latent variables. In the frame of this work, the whole Bayesian network is supposed to contain only edges identified by structured learning. In this case, it can be useful because we don't need to use some special knowledge, some experts' knowledge, and we can use only structured learning algorithms. So here you can see the structure of the descriptive probabilistic model. It's worth noting that each layer of this model has a different update rate. And we are once again convinced that this method of building the model allows us not to retrain or relearning the model completely when we, for example, get some new data on the lower level, which has the highest level of dynamic. Speaking about our study case, in this project we use data from a Russian social network which is called VK or Vkontakte, and we decided to use this social network because of some reasons. First of all, this social network has the open API, and it makes possible to take some data quite legally, yes. And on the other hand, a lot of our participants and users, they have profiles in this network. So all data that we collected, we decided to divide into 3 levels. First level is social demographic level. It's the basic level which can describe a person. It has 6 attributes like age, gender, city. So speaking about city, 1 is Moscow, 2 is St. Petersburg, and 3 is about other cities. Education has 4 levels like bachelor degree, master degree, specialties, and scientific worker. Marital status has 5 levels like married, unmarried, in love, in relationship, and single. And number of relatives is a continuous variable. The second level is about interests of a person, how we investigate the interests of our users. So in this social network, VK, each user has his own groups or subscriptions, and we just used some topic modeling techniques to investigate the distributions of topics, and we distinguished 5 main interest topics like relationship and love, money and jobs, sports, politics, and world news. And each interest topic is measured by the percent of groups with this topic. So it means if a user has a relationship and love level is about 50%, it means he or she has 50% of groups with this topic. And the third level is about social media activity. This level shows how a person is popular, how often he posts some information, how many likes he or she has, and so on. After preparing some data, we need to learn our partial networks. In this case, we use greedy heuristics, and as a score function, we use information criteria like Aggregating criteria because it's quite comfortable to control the complexity of our Bayesian network by using the penalty part of this score function. And our main algorithm was about that on each iteration we can add or delete some edge, and on each iteration we save the best structure according to the score function. After we learn our partial networks, we need to connect these networks by using latent variables, and this algorithm was about, first of all, we initialize a latent variable with a discrete distribution which represents the result of clustering of input network. It means we cluster the data of the input network. In such way, we aggregate the information about the input network, and we initialize by this distribution the latent variable, and then we refine the value of the latent variable using EM algorithm. After we construct the whole structure of our network, we need to generate synthetic data. It means we need to make sampling. In this project, we used ancestral sampling or forward sampling. Is the simplest way of sampling. It means that first of all we generate some random value in our marginal nodes, and then using conditional probability tables we generate our conditional distributions, and then we can get the whole data, the whole synthetic data. After all these steps, we get such a structure of our network. You can see that all blocks were trained separately, and then they were connected by using latent variables. And the main benefit of this method that we don't need to relearn the whole network when we add some block of information. When we get new data and we just need to train partial network and latent variables between them. Here you can see some comparison of our results. In this project we compare our method of block learning with the whole network when all attributes are learned together. And in this table you can see that, for example, when we need to train block 1 and block 2, if we don't have pre-learned block 1, we spend approximately 9 minutes for learning. But if we have pre-learned block 1, we need just 5 minutes to learn the second block, and it's less than we train both blocks together in the full connected Bayesian network. You can see that that the time of partial network training is less than we train or retrain all attributes together again and again. We also tried to compare the quality of our synthetic data by using this metric. In this formula, F and F sign are numbers of particular combinations of specific attribute values, appears in the validation dataset and synthesis dataset. And you also can see that the quality of our synthetic data by using hierarchical structure is also better. Here you can see the comparison of marginal distributions. It also can be seen that the quality of marginal distribution for hierarchical block learning is better. So, speaking about conclusions and details, first of all, I would like to note that a hierarchical structure of the Bayesian network was developed and trained, and two main advantages of this method is that the model is quite interpretable, and the modularity of our model. Second result is about sampling personal data, and it also can be seen that personal information is well structured by Bayesian networks. Speaking about our future plans, it's planned to improve Bayesian network structure by using some other algorithms of learning, And it's also interesting to investigate such question, how the structure of partial networks can be changed if we train these networks on some specific groups of users. So that's all. Thank you very much.
In this session, I'll be presenting the article entitled A Geo-distributed Architectural Approach Favoring Smart Tourism Development in the 5G Era. This work is a collaboration between the University of Bologna and University of Padua, along with a private company interested in this sort of solutions, which is Imola Informatica. So, first of all, what is smart tourism? In here comes to our help a definition provided by the European Commission, which has defined smart tourism as a combination of characteristics, starting, for example, from the accessibility, which is used to enable barrier-free destinations, enabling access regardless of age, cultural background, physical disability, and so on and so forth. Sustainability is yet another goal and characteristics, which is used to protect natural resources of a city and reduce seasonality and the inclusion of the local communities. Digitization, which denotes the use of digital technologies to enhance all aspects of the touristic experience. Concluding, another pillar and characteristic of this smart tourism experience is cultural heritage and creativity, which is used to protect and capitalize on the local heritage for the benefit of the destinations, the industry, and the tourist him or herself. In this context, web services like Booking, Expedia, TripAdvisor are some examples allowing users to plan their trips by mainly booking flights and hotels while acquiring information about the place a person is going to visit and bettering their services as a result. However, these centralized cloud-based systems propose data silos which are unable to integrate valuable local data sources at a global scale, and there is a lot of evidence of this claim in literature. So the question becomes, how do we address this problem? Conceptually, what we are proposing is a shift from a centralized cloud-based paradigm to a localized distributed approach. In this context, data are gathered, stored, and processed locally as opposed to being gathered on a centralized repository. This modus operandi allows us to serve information and data in real time or in near real time, while at the same time we can lower the transport costs associated to the data. In our reference scenario, data has local validity and relevance. The user can consult the data locally when in proximity with it. It is noteworthy to point out that our proposal is not meant to replace existing services and systems, but rather integrate with them, providing additional capabilities, enabling a reference scenario as the one described before. So, information is fetched locally based on users' expressed interests and so on and so forth. Despite the attractiveness and actual necessity for this sort of approach, it embodies some challenges which demand for a technological solution. Indeed, there are a multitude of business cases with heterogeneous requirements. As an example, in the upper right is shown a conceptual, virtualized single-user experience of a touristic site enjoyed through the adoption of immersive technologies. Yet, in the lower left is shown a potential open-door, a group-based, virtual immersive experience of the Vatican City enjoyed by the tourists. In the hospitality sector, we are seeing the emergence of the use of robot technologies to facilitate the check-in, check-out process, but not limited to it. This technology could be adopted also in the touristic sector. All these use cases might have different requirements in terms of bandwidth, latency, and number of connections served. Yet, this solution should be multi-region, urban-wide, satisfying different use cases, having the ability to scale up and down per use case depending on the demand, that is, users' requests. 5G technology could serve as an enabler for this depicted scenario, having the capability to serve a wide range of heterogeneous use cases, differing from each other in terms of bandwidth demand, latency, number of connections served, and all these heterogeneous services could be deployed on the same shared network infrastructure by adopting a 5G concept, which is that of network slicing. In the following, we will discuss some key ingredients of our proposed architectural approach. A technological pillar in the 5G ecosystem advocated to address latency, bandwidth issues, but also privacy and security issues is the mobile edge computing paradigm. In the MEC paradigm, instead of relying solely on cloud-based servers to address and respond to user requests, additional resources are deployed on the path between the users and these centralized cloud servers. These additional resources could be deployed urban-wide and help contribute to address latency and bandwidth issues, enabling a set of new and innovative scenarios such as virtual immersive reality. This localized and distributed approach to smart tourism could be the basis for deploying urban-wide innovative services and enriching the touristic experience by employing, for example, machine learning techniques such as federated learning techniques at the edge in order to enable smart interactions between the users and the services. Also, the location-accurate property of 5G could be the basis for fine-grained contextual services. We also have the capability to serve a high number of connections, and this allows us to integrate new sources of information deriving from pervasive IoT deployments. For actual use cases and services and their usage in the smart tourism sector, we refer the attendee to our article. To achieve our goal, that is provision of multi-site, multi-region solution, where we deploy a wide range of heterogeneous services, we could rely on the network function virtualization framework, which provides a common and standardized abstraction over the physical infrastructure. This reference framework also provides the means to deploy and manage services through a logically centralized brain, which is the vertical bar shown in the right part of the figure, that is the management and orchestration plane. The NAV framework also provides the primitives to compose and deploy virtualized functions, forming the so-called network services, which are the actual services deployed for the smart tourism experience. Addressing the graceful scale-up and down property of this urban-wide system, and a key ingredient of our architectural approach is the function-as-a-service paradigm. In this paradigm, virtualized network functions, which we mentioned before, are provisioned and serviced in a serverless way. Indeed, the function-as-a-service model belongs to the so-called serverless computational model, which emphasizes the absence of control and knowledge of the developer of where the code actually will be put into execution. Thus, constitutes a new promising paradigm in which stateless functions are put into execution automatically and usually triggered by some event. As an example, a user request for a particular service. Thanks to this paradigm and associated platform, the development process of new services and the upgrade of existing ones is limited to the creation of the business functionality, since the configuration, setup, and deployment of the functions is transparently managed by the infrastructure itself. The FAS model follows and adheres to the well-known event-based programming model. We generally, in this context, we talk about functions, which are the actual computational entities performing the computation as a response to a user request. The broker is the mediator between the user request and the actual function being invoked to satisfy that request. Generally, there is a one-to-one relationship between a user request and a function being invoked. This paradigm has a well-known and desirable property, which is that of a fine-grained scaling. Whenever there is a user request, there is a corresponding function being invoked and instantiated to fulfill that request, and if no request is present, there is no actual function on the other end. Putting all the pieces together, in the figure is shown the architectural approach, one of the contributions of our work. Starting from the bottom layer is the actual physical infrastructure comprised of these edge cells, which have some computational capability and also provide access to the system. The NAVI provides, along with a virtualized infrastructure manager, provides an abstraction and access to the actual physical resources. The NAVO is used to manage, orchestrate, and deploy the actual smart tourism services which are available at the VNF repository. The VNF repository, Virtualized Network Function repository, might contain primitive or composed functions which constitute the actual services. The entry point to the system is the service layer, which might be used by municipalities or even private entities to actually compose, refine, configure, and deploy the services. We now focus our attention at the FAS system feature. Recall that the idea is to provision the virtualized network functions and services following a FAS approach. To this end, we conducted a preliminary evaluation of different open source frameworks. The experiments are run in closed self-hosted environments with characteristics shown in the table. The attention is on two major open source frameworks, Apache OpenWhisk and OpenFAS. In the experiments, the FAS function answers with an HTTP response containing a simple string in its body. To emulate the HTTP traffic, the actual user requests, we rely on JMeter, a popular stretch framework able to emulate a large number of simultaneous users issuing requests against a web service. In the following, we report some results on the average response times, that is, the time taken to service a request under varying load conditions. In this particular experiment, we emulate a number of users which vary from 10 to 1,000, which resulted sufficient to perform a quantitative and qualitative assessment of the frameworks in a steady-state regime. The inter-request generation interval is set to 400 milliseconds, and the duration of the tests varies depending on the configuration. In the figure is shown the outcome of the experimentation. It is evident that OpenWhisk performs worse when compared to the OpenFAS, with the latter being more capable in absorbing the increasing load, scaling gracefully and guaranteeing shorter response times. The worse performance of OpenWhisk can be explained by its reliance on the Apache Kafka framework, which schedules and services all interactions with the platform in form of asynchronous events. While this approach guarantees a better decoupling between the framework components, one loses the efficiency and optimizations that other platforms achieve in direct and synchronous communication among specific purpose components. Moving on, Subject to this additional assessment is the cold start metric related to the bootstrap times of containerized functions. It is important to note that in fast platforms, the execution of a single function occurs inside an environment which is provisioned beforehand, and in this context, two different behaviors emerge. The first approach is called the cold start approach, also at the crux of this investigation. In this approach, the function is bootstrapped in order to service a request, and once the request is serviced, the function is shut down. The second approach, referred to as the warm start approach, the function, once bootstrapped, can service different requests of similar types, hence the function is recycled. From this basis, the cold start phenomena is faced every time the number of concurrent requests changes. To measure the cold start phenomena, same as in the prior experiment, we use JMeter to execute several parallel requests interleaved with periodic intervals of inactivity. Also, to avoid potential bias introduced by network effects, we logged the startup times of each function locally to the cluster and measured the cold start time as the time difference between the arrival of the request and the effective execution of the function. In this experiment, we focus our attention on the OpenWhisk platform and two different environments, respectively Python and Node.js. As a first result, we notice that different environments exhibit different performance trends. If this result was predictable in the case of compiled versus interpreted languages, one can notice a difference even between interpreted ones. The phenomena of cold start could be further exacerbated in presence of heterogeneous platforms, either software or hardware or both, leading to variable startup times. Indeed, an optimization of the cold start times can lead to a better usage of resources, considering these are allocated to effectively service user requests. In conclusion, in this article, we propose and discuss a dynamic and adaptable development strategy for smart tourism services based on 5G technology. Along, we propose an architectural sketch integrating the function as a service and the ETSI NAV framework. Along, we provided a preliminary evaluation of different open source fast frameworks. An ongoing work is the actual system implementation based on the ETSI-compliant Open Batum framework. As a future work, we are investigating different fast layer optimizations making use of the warm start technology. At the same time, we are investigating the extension of our reference model to support also for fog computing resources.
Hello, my name is Henrique and today I'll be presenting the work enabling QoS-secured enhanced non-public networks license for health environments. Our work is structured in 6 sections: introduction, background, testbed setup, testbed evaluation, conclusion, and future work, and finish with acknowledgements. The root of our work is 5G networks. Each have as characteristic strict requirements for several use cases such as low latency for ultra-reliable low-latency communications and high network throughput for enhanced mobile broadband. The concept behind 5G networks is to deliver the expected quality of service for each set of different requirements, and it's called network slicing. In network slicing, it's expected that resource sharing of the telecommunications infrastructure enabling the customization of isolation of concurrent data traffic, separating in different applications and users. This resource sharing goes from the virtual network functions running on data centers at the core and at the edge of the network infrastructure to the radio spectrum, which is the last mile to achieve the user equipment. For this wide range of resources to be shared, the mobile network operator, MNO, should avail from isolation of access and performance tools to achieve the expected behavior, and for that, the MNOs need complete control of the infrastructure. However, for some use cases, as in Industry 4.0 and healthcare, it's foreseen that devices will be connected to a private network, and the MNO will not be able to provide the necessary network performance for such services. Therefore, it's expected that the network has two different classes. The first and more common one is the public LAN mobile network, which is nothing more than the MNO infrastructure that provides the most part of the outdoor network coverage. The second is the non-public networks, which will deploy for private reasons such as providing indoor connectivity for sensors and robots. As the NPN standard is still on its beginning, research on this topic will be needed for the enhancement and understanding of the complexity of such topic. Therefore, projects such as Protego are very valuable to push the state of the art. Protego focuses on security for health environments, including research on network slicing to provide performance and privacy isolation to hospitals and PNs. In this work, which is part of Protego, we aim to design an architecture for network slicing in hospital environments, assess the limitation of and objectives of network slicing for hospital services, provide an open source prototype and instructions for network slicing in hospital environments. Well, some may be thinking, is the creation of such systems so necessary? According to a 2019 study done by Silence, healthcare facilities are in the top 5 targets for malware and ransomware. The study says that this is mostly caused by the massive sensitive data about patients which can be sold in the dark market. Also, the communication for critical applications that are essential for the well-being of the in-premises patients. All that leads us to the creation of private networks where the network can be physically isolated. The research on the architecture of NPNs for hospitals and environments are still scarce, and that's why Protego aims to assess not only the aforementioned network slicing, but other security techniques such as encryption key management, encrypted storing and access, and continuous authentication. This is Protego network slicing architecture. This architecture focuses to provide performance and privacy isolation for indoor private networks. The expected scenario is detailed in the bottom of the figure, where we have a smartphone connected to an access point. The access point provides one-hop connectivity to the privacy gateway, which aims to utilize different encryption methods for different slices. The privacy gateway is connected to the hospital's NPN and to the hospital services hosted in the hospital. The access point in our scenario uses Wi-Fi and is controlled by a SDR controller, which centralizes the control of several access points in the hospital. The access point has also a virtual SDN switch inside, and this is controlled by the SDN controller. The SDN controller also connects to the virtual SDN switch installed inside the privacy gateway and enables the separation of the network traffic by slices. The privacy gateway is connected to the secure interface setup, which is responsible for the centralized setup of the encryptions and tunneling over all the hospital NPNs. Above the controllers, we have the performance isolation engine and the privacy isolation engine, which are responsible to receive the technical parameters such as airtime for each slice and or security level of a slice, and to translate this information to the programs that actually implement the slicing techniques. On top of the engines, we have the slice processor, which receives high-level slice descriptions and is responsible to translate the high-level parameters to technical ones. This higher layer enabled the implementation of communication standards independent of the below layers. The slice processor also exposes an API that can be accessed by the MNO or the hospital network operator. The Protego network slicing is designed in a service-oriented architecture, which can be accessed through an API which exposes all the essential functions. Okay, now that I presented the architecture, I'm going to present the tools utilized for the prototype. Again, we separate in two classes, this time for the tools: performance isolation and privacy isolation. For the performance isolation, we deployed 5G Empower, which is an open source software specialized in downlink network traffic prioritization for Wi-Fi networks, and can provide performance isolation for services in the same network. 5G Empower is composed by the controller, backhaul controller, and the wireless termination point. The privacy isolation was implemented using the Open vSwitch, which is enabled to create a virtual SDN switch in generic purpose hardware. Besides being able to divide network traffic based on packet attributes, OVS supports also VXLAN and IPsec, which are the responsibles to create a virtual network overlay and an extra layer of encryption respectively. To experiment the usage of our NPN hospital testbed, we set up the following scenario. The wireless client connects to the 5G Empower WPT, which is, in our scenario, the access point. The client has two services requesting data from a hospital service. The service traffic passes through the privacy gateway, which encrypts the traffic for a specific services flow. 5G Empower controller, backhaul controller, and the secure interface setup were deployed using container virtualization in the privacy gateway in our demo. We could analyze the behavior patterns of NPNs with different QoS requirements with this testbed setup. Now that we know how the hardware and software are set up for the experiment, we are going to show how we validated the performance and privacy isolation. We did 3 different experiments, 2 for performance isolation and 1 for privacy isolation. For the performance isolation, we utilized an iPerf3 client in the smartphone and the server inside the hospital premises. For each experiment, we have 2 iPerf3 clients generating traffic. But for the first performance isolation experiment, it was used the UDP traffic, while the other it was utilized TCP. For the privacy isolation, we also used 2 iPerf clients to generate traffic and utilized the VXLAN network identifier to identify different slices. As can be seen in this slide, the objective of the performance isolation was to validate the expected software behavior for different protocols such as TCP and UDP using the performance isolation. The duration of the experiment was 180 seconds. The traffic generated per service was 20 megabits per second, which could overload the Wi-Fi network and give the results that we wanted. The TCP experiment started prioritizing slice 1 and equalized the airtime of the slice in second 19, as you can see in the figure above. UDP experiment starts with equal airtimes per slice, and at second 19, prioritize slice 2. In the TCP experiment, you can see that the performance isolation between the slices is implemented. And as soon as we change the rule on 5G and power, both slices starts to fight for the airtime in the access point. In the UDP chart, you can see that the same behavior happens, that at the beginning, both slices are very equal in its bandwidth, and when we change the traffic rule for the slices, the slice 2 consumes more bandwidth than the slice 1. It starts to be limited by the 5G in power too. So what we can see in this chart is that in our experiment scenario, both applications from both TCP and UDP protocols can avail from such tool for the performance to be guaranteed in an indoor environment such as in a hospital. The privacy isolation is characterized by the separation and encryption of a given traffic. So our first step in this experiment was to be able to label the network package, so we could, at the end, when passing through the privacy gateway, we could differ the packets and send it to the secure network interface, which will be implemented the IPsec protocol, which will provide an extra layer of encryption to this network flow. Or we could also send it to a network interface that's not secure at all. So what we do, first we have all the traffic passing through the VNI 10, which is a slice that is not secured by the extra layer of encryption. And in the second 90, we change the traffic from a service to the secured interface, which started to be labeled as the VNI 20. And both these VXLAN network identifiers are sent to different virtual networks interfaces. And we can see in the chart that some seconds after the rule being deployed, the traffic is already being labeled as we wanted, and this is the first step, so we can differ the traffic and send it to the secure network interface, that is the VNI 20. So we conclude that this paper presents research on NPM solutions focused on slice characteristics for hospital environments, which achieved the following results. A simplified NPN architecture for hospitals, which serves for a starting point and experimental NPN slicing, was presented in this paper. A testbed setup was implemented and described as well. The validation of the tools used and its behavior has been proven. For future work, we aim to do the communication and the abstraction infrastructure translation with MNO or hospital network operator should be assessed. And a research on the main standards for network slicing description will be done, together with the translation of the slice requirements for infrastructure configuration. The research received partial funding from the European Union's Horizon 2020 for the project Protego. Thank you.
Greetings everyone, I will present you a preliminary study where data visualization has been used to facilitate the sustainable usage of spaces in a smart campus context. Just to give you an overview, I will start describing the background and the motivation behind this work, and I will continue presenting in details our approach. Starting from the background, the spread of Internet of Things and low-cost sensors has transformed buildings in smart ones, creating a lot of real-time data that the users have to be able to read and understand to take decisions and act accordingly. Referring to the specific context of a university campus, one of the biggest problems is related to space management. Hence, the question of how to make the best use of classes and labs in terms of sustainability and efficiency. To answer this question, it is necessary to exploit the smart campus concept. Our approach is based on the use of an infrastructure for counting people based on low-cost camera and especially a web-based application to help students and workers inside a campus. Our case study is based on the New Cesena campus of the University of Bologna, which has 17 classrooms, 16 labs, 7 courses of study and more than 200 teachings. In this context arises the problem of scheduling lessons in the right classroom or laboratory depending on the number of students present and the one of the enrolled. Starting from the design process we followed, I will give you an overview of the entire system focusing on the data visualization application we developed. First of all, we identified the target groups for our application. Faculty members, as the course coordinators and the member of the course timetable commissions, were responsible to define the timetable of all the activities. Administrative staff, in charge to assist professors in defining the course timetable. ICT staff, who need to know if a classroom or lab is empty to go there to provide ICT maintenance. And finally, students, who are interested in checking if a classroom is empty to go there to study or to work on class projects. After, we conducted a brainstorming session with at least one person of each group, lasted 1 hour. A first result is the interest expressed by participants in the presented idea of using data visualization to provide data about classrooms occupancy. Second, it emerged that the different target groups have different needs in terms of data availability. In particular, students and ICT staff members required visualizations related to real-time measurements, while administrative staff is only interested in reports showing the trend of the previous course cycles. The timing is also important in defining the way to present data. Real-time data need to be presented in a detailed and accurate way, while reports can refer to a short or a long period, which means that data should be grouped and analyzed to present the more interesting information, considering both the cases. We designed and implemented a responsive web-based application with the client-server architecture. A responsive layout has been applied to all the pages in the web-based application, so they work well both via mobile and desktop devices. The mobile version is designed for quick consultation, where a larger screen is not required. For the client side of our web-based application, we used the framework Angular along with the standard web-based technologies such as HTML5, CSS3 and TypeScript. We also use some tools to implement the data visualization part, such as Google Charts, Chart.js, and D3.js. The server is implemented in Node.js and with the framework Express. The server gathers heterogeneous data both from Open Dataset and Smart IoT infrastructure. The data about the classroom and the labs of the campus, such as name and capacity, are stored in a MySQL database, while the class schedules and the information about the enrolled students are taken from Open Datasets. In particular, the data about the class schedule are provided directly by the University of Bologna as open data, and they are updated every morning to include any possible changes. This dataset was also useful to retrieve the information about every course of study, considering both bachelor and master degrees, every teaching and course units belong to a course, and the data about every classroom and labs where lectures are held in the Cesena campus. The data about the actual presence of students during the lesson are obtained exploiting the people counting infrastructure. The web-based application consists mainly of 4 pages. The first one represents all the lessons that are taking place on the campus in a specific time interval. The second one shows the usage of the classrooms in terms of time and space, analyzing their actual occupation by students. The third one represents all of the lessons taught on the campus, and the fourth one shows every course of study based on the Cesena campus. The lessons page of the web application shown in the figure lets the user see all the classroom and labs of the campus where teaching activities are taking place at the precise moment in which the user made the page request. However, the user can select a specific date and time through a date picker located at the bottom of the page. The page consists of a set of cards, each of them representing a lesson. Every card contains general information about the lesson, like name, teacher, and place where it is taking place. Moreover, it displays some numeric data about the capacity of the room, the number of students enrolled, and the number of those present in the classroom. At the bottom of the card, we decide to use a pictorial chart to display the presence of anomalies on the occupation status of the classrooms and labs. The icons of the chart are filled to show the percentage of students inside the room related to its capacity. We used the color of the graph to display the presence or the absence of an anomaly. An anomaly occurs, for example, if there are more students than the classroom can hold, or too few students compared to the capacity of that room. In this case, the pictorial graph would be red with an error icon. If there is no anomaly, the graph would be green, or yellow with an alert icon if the situation has to be monitored. Another part of the web-based application concerns the classrooms and the labs where the lessons take place. For each of them, it is possible to see the lesson schedule inside, and for those already done, the user can see the pictorial chart described before. Depending on the user needs and how he or she better perceives the information, we decide to implement 2 different visualizations to display the lesson, one using a list and the other one with a timeline. It is also possible to visualize the relative statistics to see the trend regarding the number of lessons, the number of hours, and the percentage of rooms occupation. These parameters are also used to compare 2 or more classrooms or labs through a line chart and a pie chart, as shown in the figure. All of the graphs implemented are interactive to let the user explore the data depending on his or her needs. Another section of the web-based application displays information about every individual teaching. A user can see the name of the teachers, the course of study to which it belongs, and the lessons. With a click on a lesson, a user can see every lesson that took place at the same time as the selected one. In this way, the application helps the user in charge to change the classroom for those lessons where the students present were too many or too few compared to the capacity of the room. This shift improves space management on the campus. For the same purpose, a statistics page has been created with a stack bar chart and a pie chart. Concerning the stack bar chart, we used for each month of lessons a bar as height as the number of lessons of that month. The subbars inside every main bar are green for the lessons that used the booked classroom, red for the others, and grey for the lessons that have not taken place yet. The same colors, red, green, and grey, are used in the pie chart to display the percentage for each of the categories described, as we can see in the figure. In our case study, to define if the lesson took place in the booked classroom or lab, we compared the number of students in the booked room with that of enrolled students for that teaching. If those present were less than 15% of the enrolled students, the room was not used properly. It is also possible to compare two or more different teachings. Each of the courses of study in the Cesena campus has a page on the web-based application, where it is also defined if it is a bachelor's or a master's degree. We use the list to display every teaching belonging to the selected course and a series of graphs to represent the usage of the booked classrooms or labs. Also in this case, we implemented a stacked bar chart and a pie chart to display the number of lessons where the booked classroom or labs were used. The color used for this purpose are red, green, and grey as seen before, with the same meaning. As we can see in the figure, it is also possible to compare two or more courses of study about the number of lessons and the usage of booked place. The types of graphs used are a stack bar and a sunburst diagram, as we can see in the figure. The stacked bar has the same meaning of the one seen in the previous slide, but this one uses the color of the contour line of the bar to define the course to which the bar refers. The sunburst diagram has two rings. The first one represents all the lessons divided by course, and the second one represents the percentage of room booked and used for that course. In this work, we present a data visualization web-based system that can provide different targets with a more sustainable and efficient usage of the university premises, such as classrooms and labs. We deployed our real-world case study in the Cesena Smart Campus of the University of Bologna, equipping the new building with a low-cost infrastructure to measure the classroom occupancy. Such infrastructure allows us to gather real-time data, important to provide both real-time visualization and short or long-period reports. Following a user-centered design, we engage 8 people, including students, faculty members, ICT and admin staff members, in a collaborative brainstorming session to collect the requirements. Considering the next steps, we are already planning a large-scale evaluation of the system, considering also the possibility to use our low-cost camera-based infrastructure to control the distance between students accordingly with the new COVID-19 regulation and law about social distancing. Thank you for your attention.
Hello everyone, my name is Lindberg Rennie and I'm here to present our paper towards a reference model of guidelines for the elderly based on technology adaptation factors. Right, let's get this on the road. First of all, just some little background on as to why. So according to an EU-funded survey in 2019, 20% of the EU population was aged 65 years of age or over, and according to another study that was a little bit older, where they made a review on the general ICT usage of the elderly, and in general, I also think they did, of a population in EU. They found out that almost half of the older people, so 65 to 74 years old, had not used internet during the 3 months preceding the survey. So this would suggest that they probably did not use any internet before that either. Which does suggest that there's still work to be done in as far as in getting the older generation on board in the ICT technology. So a little bit more then on this presentation. So what we're going to cover and in what order and what we did, etc. So first of all, we're going to take a quick look at some technology adaptation models. It's just quick functionalities and how they work, etc. And the two most common ones. On top of that, then we'll take a look at some web design guidelines that currently exist, and also user-centered design. And after that, we'll take a look at Shivoli's 10 adaptation factors that she derived from a literary review of technology adaptation models. After that, we'll take a look at our results of a literature review, where we'll basically take a quick look at how well web design guidelines actually cover other aspects outside just general usability. And lastly, our small contribution where we essentially use Shivoli's factors and our own findings a little bit in conjunction to provide some steps towards a reference model for user interface design. So let's get started. So first of all, the technology adaptation models. So one of the most well-known and also quite old is the technology acceptance model, TAM, published 1989 by Fred Davis, later updated to TAM2. And it only has basically two aspects to it that can directly be affected. And then these affect everything else in the chain, as you can see. So perceived ease of use and perceived usefulness. These are the main aspects in this model that one can affect. And it is quite simple in many ways, and that's why it's also been criticized that it only accounts up to like 40% of technological systems use today. Hence, it's not a surprise it was updated. This is work built on top of it, more or less, from Venkatesh and his colleagues, published 2003, UTAUT, Unified Theory of Acceptance and Use of Technology. And you can see there's already way more things influencing each other here. So first of all, now the gender, age, experience are involved, and also voluntariness of use, and then other aspects, effort, social influence, performance, expectancy, facilitation, conditions. And all these are kind of connected and then affect the chain. But this should be remarked, this is still intended for organizational use. Hence, it still lacked some aspects of factors that were then added to the updated number 2 version of the same model, where you can see first, among others, the hedonic motivation, so how fun it's to use, and then the price value, so how expensive it is, and then habit, does this break any existing habits the user might have? And then they chop the voluntariness from here, but other than that, the age, gender, and experience are still remaining in the factors. And so you can see it's like even more complex compared to the TAM. Moving on to design guidelines for elderly, essentially, and in web design. So the main thing is the Web Content Accessibility Guideline, and yes, it's not just a design guideline; it's accessibility guideline, and it's for everything essentially when web is concerned. This is from the V3 group, so essentially the people who make all the regulations for internet and the certificates, etc. And this is very rigid and very it covers a lot, essentially. And it was just recently updated because the web keeps also advancing quite a fast pace, so there's always something new they need to take into consideration. But overall, if you adhere to the VCHE guidelines, at least your website will be definitely accessible by all the known accessibility tools. But yeah, it is very rigid. There are checklists, and they even have like several levels to make it more easy. So to make it like at least the least level of accessible, essentially, I think that's how they put it. It's from 1 to 3, the levels. Additionally, then there's of course like more traditional, like Silverweb. That is essentially by created with a literary review, and then also just asking a group of all the users, and by this they came up to 11 categories and 38 guidelines. But this is very much when VCAG still has exactly in terms of code, like you have to actually. So some of the terms are just how to actually, what kind of HTML syntax you need to use and stuff like this. In Silverweb, these are more traditional usability guidelines. So image on top of text, the text should have these colors, etc., etc. So it's a bit more generic in these terms. It doesn't really care on the syntax inside. On top of that, we'll just a quick brief mention on the work done by Nurgaleva and others on a survey that they published in 2019. And they basically looked at touchscreen design guidelines, and we left this out essentially, and we just focused on pure web design. But yes, touchscreen devices are very much involved, of course, in also just browsing the web. But yeah, so these guys, they made quite a lot of work, and they discovered 434 guidelines for touchscreen devices. Interestingly, most of it, or maybe not that surprisingly even, was pretty much the same as what you would see in Silverweb or even the VCHE. So yeah, very, very similar stuff. So these are not 434 separate. These are just from different papers. So there's a lot of overlap also. But of course, there was also quite a few touchscreen device specific on button placement and screen response and stuff like this. So using the design, just briefly explain what it is. It's kind of in the name, to be honest. Evaluate often involve the users. So basically, you just have the users involved from the very step of the way all the way to the end, and you just evaluate regularly. That's more or less the idea in the nutshell. But of course, depending on the type of users, you need to take some stuff into consideration. So all the population can be a bit tricky in this aspect. So first of all, you can have cognitive and physical issues, sight, for instance, and other difficulties that you need to take according to. And also on top of that, sometimes they might also be kind of biased, either in a negative or positive way, but more or less there are some notes, for instance, regarding that they can easily don't want to offend the people doing the survey, for instance. So they might prop something up to be better than it actually is. So there's these kind of considerations. But overall, publications have propped that up to be positive. Like we have not come across with any negative experiences on user-centered design approach. And then quickly on Chavo Lee's 10 adaptation factors. So this is essentially was part of her dissertation for her doctoral thesis, and they reviewed 170 papers focusing on adaptation factors, technology adaptation factors, and focusing on elderly users. They basically came up with 10 core adaptation factors that they view to be important for elderly when they adopt new technology. And then they also noted some other potential ones that they're basically saying that there's probably more, but the 10 are the core ones, so this at the moment. But some of the extra ones they mention, she mentions in her thesis, for instance, is system reliability, service trust, lifestyle fit, and conceptual fit. But we won't cover these because they also left them more a little bit on the outside. So on the next slide, I'll just show them quickly. I won't go through them one separately, I'll just list the names. So value, usability, affordability, accessibility, technical support, social support, emotion, independence, experience, and confidence. And you have the explanations there, so I assume you can pause this video to check them out in more detail. Then moving on to our literature review. So essentially what we did, we searched on ACM Library and iExplore and Google Scholar from 2010 to present with very simple queries, so web design plus just any synonym for older persons, so aging older, elderly, senior users, etc. And we basically took 10 first matches with each combination, or up to the point where it stopped making sense, or we've had clear duplicates. And out of this, we came out with a total of 161 papers, and with these eventually weeded down to 21 like relevant papers. And the relevancy was decided by they had to give web design guidelines, actually give out like these steps or whatever. So like they had to present design guidelines, and that was the main requirement. And the next thing we did was we basically looked at the guidelines they offered and see how well they match up with LEE's technology adaptation factors. So quite unsurprisingly, 20 papers went out of the 21, 20 went directly to usability. So very similar to stuff what you would see in Silverweb, word for word for most times. And then on social support, we had 3 papers, and emotion 1 paper, and independence 1 paper. And reference model. So this is our contribution. We're working towards a reference model where we essentially looking at LEE's technology adaptation factors, how we can bring these about to user interface guidelines for the elderly, and how they can be essentially done. And we came up with 3 categories. So UID relevant factors, so user interface design relevant factors, partially relevant factors, and then irrelevant factors. So this does not mean that these factors themselves that Lee props up, and it's important to understand the difference. These are technology adaptation factors, and our focus is design factor. Sorry, it moved a little bit further. And so it says more like how relevant are these in this step of the whole work, essentially. So first of all, the fully relevant factors, of course, usability. So there's no question about it. This is among the most important steps. VCHE is an excellent way to ensure accessibility, and they are overall do consider like general usability steps also. But it's more ensuring that it's just accessible no matter what tool you're using and how much you zoom and etc. and etc. So just using this might not itself ensure that the users are actually having fun using the website. So on top of that, there is still some basic usability to concern, but VCHE does ensure that then at least no matter the requirements of the user, it should be accessible. Then emotion is essentially on the fun versus functionality. And in here, some classic ways to approach this, like gamification, playful interface, are the potential ways to go forward. Essentially, for instance, in terms of gamification, you have there are tons of different frameworks, but for instance, Octalysis is a good starting point to see the potential mechanics to use. And then on independence, this is more appearance of an application or the website or the technology, because all elderly users are worried at times that new things are a threat to their independence, that this is just a stepping stone to taking them to an old person's home or something similar, or that if they do a mistake, like, okay, now they will be deemed that they are not healthy enough to stay alone and they have to be taken away, so they might be just scared to start using a technology based on these kind of assumptions. So essentially, it's in these terms of user interface design, it's just important that the tool makes it clear that it's not a threat for the independence. So whatever the tool does is just there to help them. And this is more in the terms of the learning process also, and just the messages used in the tool, and the overall communication between the technology and the user, more or less. And then partially relevant factors. First of all, we got the value, so perceived usefulness. And this goes a little bit hand in hand with the independence. So essentially, if they don't see that there's any point to using something, of course, they are less inclined to using it. So whatever the tool is supposed to do, and whatever way it's supposed to help them, or anything, it needs to be clear. Otherwise, again, they are less inclined to using it. And this is, I think, quite familiar for anyone who's trying to get their grandparent to use some new kind of tool. Technical support, this is more in the terms of assisting as they're using it and providing the ways to learn how to use it, and stepping stones to the beginning and during, and if they have issues, how they could get help. And in these, actually, it's maybe funnily, since we are talking about technology here, but there are some suggestions that printed manual are quite efficient because it's familiar for the elderly user. But of course, then the issue of like, if you need to update something or anything happens that are like changes drastically in the tool, you need to now make either a new manual or using the old ones are pointless. So of course, the best way to go about here is the combination of several different things connected. So the digital manuals with the printed manuals and easy access for aid. So the printed manual might best work as a general guideline on how to get the help on the tool itself, for instance. Social support basically covers all the aspects of, for instance, anything connected to communication with other users in the tool or outside the tool. All these social bubbles in and out. The big social network tools have already provided quite a few good examples on how these can be done. But you have the classics of cooperation and cooperation, maybe competition even at some points, and anything in between, essentially. Experience, essentially in this case, because the elderly user might not have any previous experience to compare to, it's more about personalizing the tool so that it's more familiar for them. And the confidence is all about making the tool so the mistakes are not scary, essentially. Any mistake the tool might happen, or errors that might happen, are not hazardous for the user. So basically, that they don't need to worry about that they can break anything. That's essentially it. So basically, any serious errors should be and needs to be hidden from them, and any minor ones need to be worded clearly that they are minor ones, even if they're not. And lastly, the relevant factors, so affordability and accessibility, are more about the requirement analysis, and they just do not carry any weight at this stage of the design process, essentially. Yeah, there's not really much otherwise to say about them. All right, that's it. Thank you very much, and I guess there will be questions.
I would like to give you all a warm welcome in this new academic reality of online conferences. My name is Agnieszka Kolasińska, and I am a PhD candidate in Brain, Mind and Computer Science at the University of Padua. Today, I will be speaking on behalf of myself and my three colleagues, my co-supervisor Professor Ombretta Gaggi, and Professor Silvia Mirri and Katia Prandi from the University of Bologna. Working on this presentation has actually been a great opportunity for me to gather some deeper understanding of the topic of our research. I was wondering how to prepare an interesting and engaging speech without my personal appearance on the conference stage. And I suppose it is a challenge that most of the teachers in the world have been facing over the past couple of months. Except for the fact that I am talking to the community of grown-ups who made a voluntary choice to listen to me and who in the worst scenario will end up being slightly bored and turning the video off before it ends. I believe we would all agree that the responsibility assumed by the teachers and the challenge of capturing and holding children and teenagers' attention are not comparable to what I am doing right now. In today's presentation, I will be talking about the challenges of distance learning and the consequences of the rapid educational shift we have witnessed this year. I am sure we were all affected in one way or another by the pandemic crisis we have been facing this year. Therefore, I will not devote much time to illustrating the problem of COVID-19 emergency. I would like to focus, instead, on one of the most affected public sectors, which at the same time happens to involve one of the most vulnerable social groups, youth. By the beginning of April, over 1.6 billion of students in the world have been affected by the closure of schools, universities, and colleges. Italy was among one of the first countries affected by the emergency. Therefore, the interruption of education occurred even earlier than in other parts of the world. Starting from the 4th of March, schools and universities have been closed nationwide, and gradual introduction of distance learning has been implemented. Inspired by this sudden shift from traditional to distance learning, we decided to investigate the general sentiment, impact, and settings of the Italian distance education. We created an online survey that was administered to over 1,000 parents of Italian students. The results I will be presenting today, however, refer only to a sample of 490 respondents, being parents of primary school students. As demonstrated in the current slide, we tackled three main aspects of the new teaching modality: organization of the distance learning, studying environment and equipment, and the impact e-learning has on the students and their families. In the first category of questions, we aimed at understanding if a given school decided to activate distance learning, and if so, what was its modality. The second group of questions provided us with insights into what technological devices are being used by the students most frequently and in which context. Finally, we asked our respondents about their perceived burdensomeness of the new teaching modality and the impact it might have had on their children's competency in using technology. In the current slide, you can see an overview of our respondents' demographics. We collected data from 17 out of 20 Italian regions, yet, as can be easily noted, most of the responses come from the three most affected by the pandemic regions of the country, which is Veneto, Emilia-Romagna, and Lombardia. It is not surprising, as we primarily used our personal contacts to start the snowball sampling procedure, yet it might have influenced the collected data in various ways. On one hand, as already mentioned, these three regions have been hit the hardest by the COVID-19 pandemic. However, at the same time, it is the wealthiest part of the country, which may influence, for example, the accessibility of technological equipment. 4% of the participants enrolled in the study admitted that distance learning has not been activated in their children's schools. It does not seem to be a lot, but if we take into consideration the fact that by distance learning we intend any kind of educational activities, from the active ones being the most demanding and time-consuming for the teachers, such as online lessons, to passive ones, which include sending textual files via email and checking students' homework, it emerges as a critical finding. One possible explanation of this interruption of education might be the issue of high-level coordination of teaching activities. As demonstrated by the collected data, there is a high variability in the modality of activation of distance learning. The responses of our participants were almost equally distributed between school and class-level organization and individual teachers' initiative. It points to an important problem of lack of general procedures and protocols. While it is commonly understood that the education shift has been sudden and unexpected, these organizational deficits still left many of the parents disappointed. The lack of consistency can be observed not only in the initial steps of setting up distance teaching activities. The same problem occurs in the context of implemented modalities of distance learning. A common practice appears to be combining various asynchronous learning activities, such as video or audio recordings prepared by a teacher, sending PDFs or textual files together with homework to the students, or sharing useful links and digital resources. Less common appears to be giving online lectures. Similarly, a broad variety of options emerges from the investigation of the most commonly used teaching platforms. There is a lack of general agreement on which of the available services to use. Google Suite for Educations appears to be most widely used. Almost half of our respondents admitted that their children use services offered by Google for educational purposes. Surprisingly, before any other platform specifically designed for teaching activities comes WhatsApp, a well-known application allowing users to send text or voice messages, pictures, documents, and other media content. It is followed by Nuvola, a system adopted by some of the Italian schools as an official digital school register, and Zoom, a popular software for video conferencing. The confusion caused by navigating between different platforms, various digital tools, and changing schedules appears to be one of the reasons for parents' feelings of exhaustion, frustration, and overload. As illustrated by the graph, a vast majority of parents perceive their workload related to the distance learning activities as heavier or even a lot heavier when compared to the usual pre-quarantine assistance in their children's education. On the contrary, when asked about their perception of their child's workload, almost the same percentage of the respondents evaluated it as heavier as the number of parents who consider it to be lighter. 14% of the participants did not notice any difference between the students' work burden before and during the times of the pandemic. With distance learning being fully dependent on the access to digital resources, the availability of technological devices and stable internet connection is of a crucial importance. While most of the respondents' children appear to have internet connection of fairly good quality, it is a cause for concern that 74% of the students share their computer or other technological device that is used primarily for educational purposes with other family members. It might be of an issue to plan a daily studying schedule when there is more than one school-aged child within a household, or if also parents are required to work from remote using the same device. As can be observed in the current slide, in some cases, students share their devices with more than one family member, meaning that the demand for it is always high and it is possible to use it only within a specified time window. On a positive note, the sudden transition from traditional to distance learning had a positive effect on children's computer literacy. as most of the students before the COVID-19 emergency were little or very little confident in using technology, the fact of incorporating it into everyday studying routines significantly improved their capacities. It proves that even when considering only the youngest group of students, they are capable of adapting to a new situation very quickly and fairly easily, and they acquire new skills accordingly. Despite the study being mostly focused on the exploration of different modalities of distance learning and the impact of availability and adoption of various technologies, we believed it to be of a great importance to tackle also a wider aspect of psychological, emotional, and social well-being in the context of this educational earthquake. Therefore, we gave our respondents the possibility to express their thoughts, feelings, and concerns in a comment section of the survey. The most prominent message deriving from these comments is the impact of distance learning on children's social environment and interactions. The parents emphasized the importance of face-to-face communication, not only in terms of fulfilling social needs of the children, but also with regards to keeping students' enthusiasm and motivation on a high level. It is well illustrated by the quotations that you can now see on the screen. Another important concern of the participants of our study is related to the difficulty of children at such a young age to stay focused while looking at the computer screen for a prolonged time. They point to the need of the youngest students for a constant stimulation and structured studying environment and schedule. So, putting it all together, what conclusions can be drawn from the presented results? Well, to start with, it is pretty straightforward that we were not prepared for this sudden and unexpected educational shift. High-level coordination in the decision-making process was lacking, which resulted in the distance learning being rather disorganized and cumbersome. There is a clear need for the common guidelines and best practices when it comes to distance learning, in order to avoid both teachers' and parents' confusion and the feeling of being overwhelmed. Unfortunately, as for the present moment, the experience of parents with e-learning was rather negative. They consider it to be a heavy emotional burden, and lots of them struggled to combine their work-related obligations with helping children to complete their assignments. Without a doubt, in this research, we focused on the most vulnerable group of students. The youngest children unquestionably require particular assistance and more individual attention than their older schoolmates. Nevertheless, they are the ones who need educational guidance the most, and therefore it is of utmost importance to be able to provide them with it, even within the context of an emergency. I would like to close this presentation with a little reflection on what we can learn from these recent events in the context of education. First of all, I believe it is important to emphasize that despite the identified difficulties, technology can have an important role in education. Distance learning, if well structured and organized, can be of a great additional learning support for the students. It can be applied to a variety of contexts, and it can make it easier to, for example, catch up with the studied material after a prolonged absence of a student. What is clearly necessary, though, is to prepare some common guidelines and best practices for schools and teachers involved in distance learning. They shall not struggle with navigating between endless technological and software possibilities, but should be provided with general recommendations and principles. Last but not least, the current crisis has pointed to one very important role of the school system, other than pure knowledge acquisition. School is a crucial agent of children's socialization. It helps young people to develop skills and competence that will allow them to function and interact with their environment. Therefore, When reflecting on new teaching modalities, the social context of education and formation cannot be overlooked. I would like to thank you for your attention. I hope I have managed to hold it till the very end of this presentation. In case of any questions, I encourage you to contact me or one of my collaborators. You can see all of our email addresses displayed on the screen.
Hello, my name is Kiyoshi Nakamura. I am collaborating with the Group of Computer Networks GRC at the Polytechnic University of Valencia. Now I will tell you a bit about our paper, Adapting Voice Messages to a Low-Cost, Low-Range Data Messaging System. Digital networks are expanding fast, but they're still a long way from being universal. The UN defines being online as having used the internet from any device in any location at least once in the past 3 months. The map of the blind population highlights regional differences in internet usage. Countries with the highest shares of people not using the internet are mostly in Africa and South Asia. In developed countries, most people are online, with close to 87% of individuals using the internet. Most of the blind population lives in least developed countries. In the LDC, on the other hand, only 19% of individuals are online in 2019. Europe is the region with the highest shares of internet usage rates. Africa, the region with the lowest internet usage rates. Another problem worldwide is illiteracy. According to UNESCO data, about 750 million adults are illiterate, 16% of the world's population, 64% of whom are women, still lack basic reading and writing skills. If we analyze literacy in all regions, we can see that Africa has the highest percentage of illiterate population in the world. In summary, these two problems represent a great disadvantage for many isolated communities. LoRaWAN is a low-power wide-area network specification intended for wireless battery-operated things in a regional, national, or global network. LoRaWAN defines the communication protocol and system architecture for network, while the LoRa physical layer enables the long-range communication link. LoRa is patented and acquired by Semtech, which also has developed this wireless communication technology. Now, the LoRa Alliance, an open and not-profit association, is responsible for the development of standards and their evolution. The communication frequencies that LoRa use are mainly those which operate with ISM band, although the technology can operate at any frequency below 1 GHz. LoRa usually operates in the bands 433 MHz, 868 MHz, and 915 MHz. Depending on the country, these bands may be restricted. Spreading factor is a key characteristic in LoRa. The spreading factor are, in short, the duration of the strip. LoRa operates with the spread factors from 7 to 12. Spreading factor 7 is the shortest time on air. Spreading factor 12 will be the longest. Each step up in spreading factor doubles the time on air to transmit the same amount of data. With the same bandwidth, longer time on air obviously results in less data transmitted per unit of time. The overall architecture that we are proposing consists of hub devices that have different wireless technologies. The hubs will communicate and send messages to each other using LoRa. In addition, they will be able to collect data from external sources, that is, inputting data from a simple temperature sensor to a voice recorder via Wi-Fi. External sources connect to the hub through a Wi-Fi link, but also Bluetooth can be an option. These sources are integrated in the platform and talk with the hubs using a REST interface. The transferred data is structured as a JSON object. The data contained in JSON object can have a variable size, limited only by the slow data rate that we can obtain from the LoRa channel. Topics average length can range between 10 to 50 bytes, while values can be anything from a few bytes to hundreds of kilobytes, like in our case with the voice recording source. For the hub prototypes, we are using the PyCom LoP4. These devices integrate various wireless technologies and are based on MicroPython. They are low cost and low energy consumption. Here we can see some of the prototypes that we have used in our experiments. The device in charge of recording audio is a Raspberry Pi 3 Model B Plus. We have mounted a 1.44-inch LCD screen. It has a joystick and 3 buttons, which will serve as an interface to control the audio recording process. Before starting the process of recording a voice clip, the user must identify himself. Once they have been identified, the user will be able to see their photo and 3 icons that will indicate the function of each button on the screen. By pressing the Q1 button, the device will start the audio recording, and it will be indicated with an image on the screen. The recording can last up to 50 seconds. The user can stop the recording process whenever he wishes before that time by pressing the key 2 button. If he doesn't stop it when the maximum time is up, it will stop automatically, and an image will show to indicate it. If the user wants to listen the voice clip before sending it, they will have to move the joystick to the right, and they will start listening to what they have recorded. To send the voice message, the user must press the key 3 button, and then will have to choose the destination user. When the user records a voice clip, a WAV audio file is generated on the Raspberry. Our solution is capable of sending messages of up to 100 kilobytes. For this reason, we have to compress the generated audio file. Using a framework that can manipulate multimedia files, we compress the WAV file and generate an MP3 file. In this table, we can see the size of the files with different durations in their WAV and MP3 versions. We have done communication tests between the LoRa devices in 2 viewpoints, which are located 6 kilometers apart in Chiapas, Mexico. Both locations are high enough so that buildings do not interfere with the device's line of sight. In these images, we can see the scenarios in which we have done the communication tests. The source device is in location A, while the target device is in location B. During our test, we have transmitted messages of 1, 10, 50, and 100 kilobytes. As a result of the test carried out, we obtained this graph, which shows us the increase in successful transfer time (STT) as the size of the message increases. STT measures the transfer time of the message from the point of view of the sender. It is computed from the moment the first fragment of the message is sent to the moment the last ACK of the last fragment of the message is received. We have presented the design of a low-cost, low-power solution to provide messaging to isolated communities. We describe a voice messaging system that allows users that cannot read or write to send voice-based messages. The voice messaging system was integrated in an existing platform and presented some results on its performance. The results obtained show that this solution can offer a low-cost and efficient solution for the context we aim to. Moreover, this architecture can be extended and used for other applications like to offer weather forecasting data, healthcare information, market prices of crops, and so on. More testing with different LoRa parameters and setups. Improve the user interface by having it tested by various users to improve the data compression so either allow for longer messages. Reduce the time required for the transfer. Messages relaying helps forward messages among themselves to extend the reach of the system. Mobile hubs using a bus or other public transportation vehicle that traverses areas not served by cellular operator.
I'm Davide Berardi, and today I will present you our project I made with my colleagues on sustainable infrastructure monitoring for security-oriented purposes. So, the infrastructure we focus on are infrastructure with extreme modularity, with responsiveness, so are easy to change the topology of this infrastructure of interoperable devices, are cost-effective, so it has low device expensiveness and low operative expensiveness. It ideally employs softwareization, so modern infrastructure employs SDN and NFV, which we'll present in the next slide. And the main topic of this presentation is the security of this infrastructure. So, for example, we focus on resistance against denial of service attacks. I said that we employ two technologies of the modern infrastructure, like SDN and NFV. SDN, why it is not the central focus of this paper, is the virtualization of network routes and paths. In this example, in this image, we see that a centralized entity, a logically centralized entity, which is called the controller, dialogates with switches, with devices. For example, switches send to the controller new flow they see, and then the controller can send the configuration. That is a big improvement from the previous infrastructure of the network, in which switches are somewhat not elastic to changeness. So, for example, if you need to change a configuration of VLANs or a configuration of the parameters of the spanning tree protocol, you need to configure every parameter on every switch. In this case, the controller automatizes this process using a centralized point in which you configure these parameters. It can be used, for example, to hijack communication. So if you have a high traffic load or some traffic you want to inspect, you can, for example, tell to the controller when you see this traffic shape or this traffic properties, hijack to this part of the network which contains a network analyzer of some kind. NFV employs virtualization but of network functions. In this example, in this image, you see that we have a firewall and a router which get implemented as a network function over a set of virtual machines. For example, this can be used to set up the router or the firewall only when needed. So if you don't need the router all the time, you need the infrastructure, you implement it only when you need. And that can make your infrastructure more elastic to the changes, so you can change the infrastructure on the fly, and more cost effective. For example, you can use this kind of responsiveness to change the shape of your network infrastructure and set up only the part you need, keeping the other parts shut down, so they not burning over your costs. So the question for now is, in a world where we use NFV and SDN, how we can monitor this kind of dynamic infrastructure which grows dynamically and is not static? That is the point of our paper. Also, using SDN, we need to provide to the SDN the information when to change the network. So, for example, I said that SDN can dynamically reconfigure all the layout, all the flows in the infrastructure. How we can tell the SDN controller, change the network infrastructure now, change the network topology now, and hijack this traffic to an inspection chain. That's the infrastructure we focus on. In our setup, we used open source Mono, which is a network function virtualization orchestrator. In this case, in the figure on the right, you see that we have a cloud platform, which is OpenStack in our case, which is called the VIM, Virtual Infrastructure Manager, on which we implement the virtual network functions. So for example, is the orange box you see over the OpenStack box. This Vim dialogues with a VNF manager, which decide when instantiate the network function and monitor them to see when to shut down or restart them. That's the work of open source Mano. We will see that we have used a specific version of open source Mano, which can get automatically deployed over our system, and that will facilitate the task of monitor we want to do. As the monitoring part, we set up a time series database. This database has a concept of time. So every data which gets inserted into the database is composed of the value itself and timestamp. In this case, you see that an idle time of a CPU get a specific value at a specific time. So with this, we can automatically get graphs and time development of data. This can be really useful for our infrastructure because we can set up a Prometheus node which monitors a certain part of the network, and so the load gets distributed. Then every Prometheus node needs to be aggregated with a specific visualization and alarm platform. This kind of alarm platform, which is used to query Prometheus data and to analyze if we are under certain condition with designate an attacks, which could be the first alarm of an attack, is Grafana. Grafana, as you can see in the picture on the right, which is one of the typical visualization of Grafana, is a platform to create dashboards and alarm routines. So we use Grafana to aggregate the various Prometheus nodes we had in this infrastructure. So we don't have a multi-data center cluster, we only have some machines. We only have 10 machines, and we monitor it using Prometheus. We use 3 Prometheus and monitor it using Grafana and aggregate the data. So in this example, you see a single machine with its GPU, its RAM available, its memory available, and a graph which indicates the transmission, the use of the network. For example, you see that we have a big spikes in CPU, we have a consistent consumption of RAM, and some kind of transmission spikes at the end of the graph. That can be used to designate alarms and to set procedure to do. For example, in this picture, you see that the system administrator set the policy to send by email when the CPU data get over a certain threshold. As I said before, we haven't used a vanilla open source Mano, but we have used the specific version of open source Mano, which can be used using a paradigm called infrastructure as code. That can be used also to set up Prometheus and Grafana. So we set up all the entire infrastructure using this technology, which gets implemented by a software called Juju, a software by Canonical. The Juju practically can be used using configuration files, which are the specific instruction to set up open source Mano, Prometheus, and Grafana. And with this paradigm, you can dynamically reconfigure your network, setting up Prometheus and Grafana only where they needed, or to change dynamically, changing configuration file, your topology and machines where to implement Prometheus. This also opens up to a security aspect of our infrastructure, which can be the analysis of the configuration. For example, we can see if the configuration has some critical points, like some kind of not changed password, by looking only at the code. And the code could be maintained by using VCS, versioning control system, so for example, using Git. That is a big addition to classic infrastructure, in where if you need to do a penetration test, you basically need to enumerate everything, and to check every part of your system by using specific tools. As a test, we replicated an attack we saw some time ago, the denial of service attack over our servers, and we simulated it for a time step of over an hour. We monitored it using the proposed technologies, and we saw the following results. The picture on the left is the normal situation, so you see it's a pretty consistent situation with no spikes, with no strange data, with not strange spikes of data. And the picture on the right is the RX byte, the amount of received bytes during a denial of service attacks. So, in this case, you see a lot of big spikes. The amount of data is something like 1,000 times bigger than the left one. So that's easily detectable by Grafana and Prometheus. Using network probes, you can easily check if we are under attack and send an alarm to the network administrator. It can be also used to reconfigure the network by using SDN. In our case, we haven't done that in this work, but in a previous work. And using this kind of technology, you can basically make the denial of service attacks less powerful. For example, by hijacking the traffic to a drop chain, or maybe drop the every traffic in the switches or in a firewall, or setting up firewall using NFV dynamically. This will destroy the performance of denial of service attacks, because you basically target the traffic when it gets generated and you drop it from the source, minus the responsive time used to set up hijacking rules. As a conclusion, we propose some future works, one which employs the extreme modularity of our system. In this example, you see that we want to substitute Grafana to Kibana, which is an alternative platform from the Elastic Stack, which can be used to create dashboards and alarms which get presented to the user. That can be done easily, exploiting common APIs between the two services. Grafana and Kibana use compatible APIs, which can be used with a later configuration in the targeted system. The other one employs another component of the Elk stack, freely available from its developer, which is the XPack extension pack of Kibana. Using this kind of extension, you can issue algorithms over your data. In this case, we want to use anomaly detection to check anomaly case and inspect them using SDN. This also can be done easily if we introduce Kibana in the loop. And then can be used to reconfigure the network dynamically using machine learning. On a side note, it will decrease determinism a little. So at the time we haven't implemented it. So I wish to thank you to see my presentation. I hope you have questions. I don't know if you have already done it, but I'm here to ask your question. Thank you.
Good morning. My name is Guillaume Spala. I am a PhD student at the Université de Sherbrooke, supervised by Professor Charles Gouin-Valéran and co-supervised by Professor Nathalie Bière from Université de Montréal. I'm going to present you the work of the article titled Towards an Augmented Reality Cognitive Orthosis to Assist People with Alzheimer's Disease Preliminary Design. This work has also been done in collaboration with Amélia Daden from Université de Montréal. First, I will start with an introduction. Next, I will give some experimental and computational details of the prototype. In the third section, I will present the evaluation and the results. Finally, I will give a conclusion and present the future work. Alzheimer's disease is the most common form of dementia, representing about 50 to 60% of the cases. To live independently at home, people with neurocognitive disorders must be able to perform activities of daily living and instrumental activities of daily living. Activities of daily living refer to the basic personal care actions related to hygiene and health, toileting, feeding, dressing, etc. Instrumental activities of daily living refer to the more complex activities that enable a person to live independently in her community, such as cooking, grocery shopping, finance, and laundry. Some people with neurocognitive disorders could still live at home independently if they have assistance for some of their instrumental activities of daily living. And for people living in rural areas, sometimes this assistance can take the form of a synchronous remote assistance provided by a caregiver. If we provide a remote assistance using audio and video, nowadays this is mainly done using an intermediary display, which forces the user to split his attention between the task and the assistance. In this example, I need to split my attention between the actual making of the recipe and how to make it, which is displayed on the laptop's screen. And the difficulty to focus is a frequent deficit in Alzheimer's disease. So, to avoid the user to split his attention, we propose to use augmented reality, or AR. This is an interactive technology consisting of superimposing virtual images or additional information on real-world images in real time from a display device. In this example, the information about how to make the recipe is shown directly in my environment, so I do not need to split my attention between the environment and the laptop. We can see two main categories of AR devices: handheld displays, or HHD, and head-mounted displays, or HMD. HHD provide AR through a device held by the user, typically a smartphone. HMD present virtual images right in front of the user's eyes. No other physical objects come between the eyes and the virtual image from the display, which guarantees the virtual image not getting occluded by other physical objects. Today, the HHD have a better social acceptance than HMD, but we have to think long term, and the technology will definitely evolve in the next coming years. That's why we have selected HMD. Indeed, as I already mentioned, they present the image in front of the user's eyes, and they also offer higher mobility experience than HHD by, for example, letting the hands of the user free. Several studies have explored the use of synchronous remote assistance, but to the best of our knowledge, none of them focus on the use of an AR HMD for synchronous remote assistance of people with dementia. They also did not evaluate the cognitive load of such solution, although it is an important factor to take into account while designing for elderly and people with dementia. Our goal is thus to make a first step towards the direction of designing cognitive orthosis for people with Alzheimer's disease using an AR HMD by exploring synchronous remote assistance. The design of our solution is based on the principles 3, 4, 5, and 8 of the zero effort technologies, or ZET principles, which have been defined by Alex Mihailidis. The third criteria of the ZET says that the interfaces must be intuitive, simple, and when possible integrated to the user's environment and context. The fourth criteria says that the solution also has to stimulate the user to interact with its environment. To fit with those two principles, the AR HMD Microsoft HoloLens has been used. Indeed, contrary to other types of AR HMDs, it is capable of understanding the end user's environment thanks to its numerous sensors. It is thus capable of, let's say, adding virtual objects in the user's environment. So there is no intermediary between the user, the assistant, and its environment. The ZET 8th criteria explains that the solution should be designed for expandability to new functionalities and compatibility with other technologies. The HoloLens does not require to install additional sensors in the user's environment. It also comes with Wi-Fi, Bluetooth, and Windows support, which makes it a device we can easily connect to other computational units. Let's now have a look to the prototype. I would first like to mention that the illustrations shown here are simulated because the HoloLens I have was broken at the time of recording this presentation. But the application runs the exact same way. Let's assume that in this image, the user who needs assistance is currently wearing the HoloLens. The caregiver has access to this dedicated desktop application. The communication between those two components is initiated using a WebRTC communication. The communication is audio and video, and the HoloLens comes with a webcam, and thus the webcam's stream is sent to the remote computer. So the video is unidirectional and the audio is bidirectional. There is also another UDP channel to stream data between the two systems to keep the two components synchronized. The graphical user interface you see is the graphical user interface of the caregiver application. This supports the ZET 5th criteria, which is supporting the caregiver. Using the toolbar on the top of the interface, the caregiver can add annotations in the environment of the user wearing the HoloLens. 4 actions are possible. Add a target sign. For example, the user selects the annotation, then moves the pointer to the place where he wants to add it in the environment of the user wearing the HoloLens, and finally he clicks to add the annotation, here to the dresser. We can also use the same process to add a no entry sign, and we can also add a directional arrow. This arrow always appears in front of the user wearing the HoloLens and points to where the caregiver has clicked, and the direction of the arrow also adapts when the user moves. Finally, we can also send a text message that appears for 20 seconds on the top left corner of the user wearing the HoloLens. The icons and actions are kept very simple with an explicit meaning on purpose. But the caregiver is using a 2D environment, whereas the user is using a natively 3D environment. Consequently, to accurately position its annotation, the caregiver should manage the X, Y, and Z coordinates, Z being the depth. Managing the X and Y coordinates is easy, as it is directly mapped to the mouse cursor. But managing the Z would require a long step. So it is assumed that the caregiver wants to map the annotation to the object that is, let's say, underneath the mouse cursor. To do that, when the user clicks on the video stream, the coordinates of the 2D images are sent to the HoloLens. Then the HoloLens, thanks to its sensors, is doing a research of the first hit object. Finally, the annotation is positioned at those coordinates. To evaluate this system, we had 2 hypotheses. First, that the solution has a good usability, and second, that the solution requires a relatively low cognitive load. 8 healthy neurotypical participants took part of the study, aged between 24 and 38 years old. One of them is an occupational therapist. The data collection is done through observations, the filling of the NASA task load index, the SUS questionnaire, and after that concluded with an open discussion. The selected scenario was for the caregiver to provide a remote assistance to the user wearing the HoloLens, who has lost 2 objects in his apartment. The caregiver knows where the 2 objects are. This test scenario was defined based on the fact that people with Alzheimer's disease are more likely to lose objects, and the assistance of a caregiver might be useful in this case. The assistance can obviously be given only by means of the application, which means using virtual annotations and audio. The caregiver is located in a room outside the apartment. Let's now have a look to the results. For both the caregiver and the user, the effort was high. Regarding the user wearing the HoloLens, having the effort above average is a concern. It is also a surprising result, as first, the HoloLens application is limited to the minimum, with almost no interaction and very few information displayed. Second, that some participants had the feeling to not performing well, whereas, as I already mentioned, they had no interactions to perform with the system. And third, that some participants felt under time pressure, whereas there was no time limit to perform the task. The conclusion is that more investigation is required to understand the reasons and find alternative solutions to reduce the effort before considering an evaluation with people with Alzheimer's disease, who will most likely be less familiar with technologies and require a higher cognitive load to accomplish the task. For the caregiver, the temporal demand was above average. It shows a low physical demand, which was expected due to the fact that there is only a desktop software to use with minimal physical efforts. The SUS score are lower than expected, as the average is 73, and here the score for the caregiver is 65 and 68 for the user wearing the HoloLens. So usability needs to be reconsidered for both the caregiver and the user. From the feedback sessions, we can highlight the following remarks. To precisely add an annotation to the environment, the user wearing the HoloLens must keep his head as fixed as possible, which is difficult for an elderly or a person with Alzheimer's disease. Indeed, during the evaluation, the caregiver often had to ask the user wearing the HoloLens to stop moving and to look to a precise location. So, in this context, the audio assistance in combination with the video stream is preferred, because adding the virtual annotations was not always easy. This might partially explain the higher level of frustration, effort, and temporal demand. A stabilization solution could be implemented, or a way to freeze the image, as presented in some articles. Furthermore, thanks to such feature, the person wearing the AR HMD does not have to keep his head steady. It can also help by going towards a direction where video interactions are as efficient as audio interactions, which can help the caregiver to convey his message. Another remark is that the directional arrow can only give a direction on the field of view of the user wearing the HoloLens. A potential solution could be to display a virtual map of the user wearing the HoloLens on the caregiver's application, so that it can make the arrow pointing to a location outside the field of view of the user wearing the HoloLens. Participants also told us that the annotations are seen as being clear and useful for specific cases, as when speaking is not sufficient, but more flexibility should be offered. They could be moved, resized, allow hiding or highlighting part of the environment. The design should be done carefully to avoid making the software too complex, as it has been noted that the annotations, in their current states, are straightforward and explicit to use. We have to say that this study has several limitations. Our goal is to evaluate if AR could be potentially beneficial in this context. So it is supposed that the participants accept to wear the HMD. Participants to the study are all young and healthy. The participants are also all familiar with quickly grasping new technologies. The scenario could be more realistic. For example, the caregiver might not know where the objects are. 5 sessions is really the minimum for such evaluation. We also do not take into account the cost of the device, the weight, the latency of the interactions, or the questions of privacy, as we really wanted to focus on seeing if AR could be beneficial in this context. This work has presented a preliminary step towards an AR HMD cognitive orthosis. This first experimentation aimed at evaluating this prototype from usability and cognitive load point of views in order to improve it before performing an evaluation with people with Alzheimer's disease. Several steps are foreseen in the near future. A new iteration of the prototype will be done to deal with the identified usability issues. We are foreseeing to do an evaluation with people with Alzheimer's disease, although this might need to be delayed due to the current situation. The functionalities of the prototype could also be tuned for people having other types of neurocognitive disorders. For instance, in the case where speaking is not sufficient, which can be the case for certain type of agnosia. It is also foreseen to demonstrate this technology to occupational therapists during focus group sessions to stimulate feedback in order to refine functionalities and scenarios. That concludes my presentation. If you are interested by the code, it is available in a GitHub repository, which address is written at the bottom of this slide. Thank you for your attention.
Hi, I'm Kevin Bouchard. I'm a professor at the Université du Québec à Chicoutimi in Canada. Today I'm presenting a paper entitled Features Exploration for Grades Prediction Using Machine Learning. My co-authors are Luca Gonzalez, which is a master degree student, and Julien Maître and Sébastien Gaboury, which are both professor with me at Université du Québec à Chicoutimi. So basically this research is part of a bigger trend in Quebec. So Quebec is starting to do a digital shift in education. Quebec, along with the rest of Canada, is late to the party. So basically many countries are in advance compared to our educational system regarding digital and digitization of information in the school system. Our motivation comes from a platform that is called Eco-Soutien Scolaire, which is a platform that was developed by a small company here in Quebec called Optania. It has been running for a few years now, and basically the platform is used to digitize the grades, the non-attendance of the student, the behavioral events, and other comments that educator can have on their progress on the students overall. There is some basic AI currently that provides a bit of few insights on the progress of the student. Mostly it is used to raise alarm if there is something bad going on with the specific students. The motivation is that basically we think that machine learning should play a key role to leverage this kind of platform. So now that we are able to digitize the information about the students with machine learning, we should be able to exploit it in a more intelligent way. So for instance, we could probably be able to predict the at-risk students, but also define better intervention strategy when we find those at-risk students. And hopefully this is maybe a more bigger picture, but hopefully these kind of technology could help in reversing some very bad trends that has been going on in the past few years, if not past few decades. So basically, one of these trends is that the graduation rate for males in high school is going down years over years, and it has reached a low point of 68%. And for those not aware of, for those of you that don't know the school system in Canada, in Quebec in particular, basically without an high school degree, it's very unlikely that you're gonna find work. So it's very troubling to see that 32% of males are not graduating from high schools. The problem is not as bad for females, which is, if I remember, just a bit below the 80% rate. We also have an increasing non-attendance through the province, which is quite bad. So the data that we used for this school project, we obtained it from passing an ethical certificate. We were not able to have access to the comments or behavioral events, but we were able to have all kind of information about the grades and the non-attendance of the student, which was good. The data represent 4 school years, and we have students from the first year of primary schools through the last years of high school. And basically, these students are range from 6 years old to 17 years old. There are 5 school years in primary school and 5 school years in high school. The data is divided, the data came, we think, from a database because we received 5 files that were structured similarly to a table in a database. These are the stats for each files. Some of them included information on the group, the student group, the school, and so on. Some information about the exam and the tests that were completed by the student, and also we had a file about the absence of the student, about the student exam, and about their term results for each subject. And as you can see in the bottom table, these files are actually quite big. So some of them, for example, the file D for the school years 2016 is more than 1,300,000 lines. So there's a lot of data going in those files. However, as you can see, there's not that many columns, but that's because the data is structured as a table in database. There's no missing data and duplicate. I'll come back on what we did with this later. From these files, basically, we transform them into instances that represent 1 student for 1 school years. So we have all the information on the student, then we have all the grades on each subject, all the absence on each subject for each of the 3 terms. And then we also have some basic statistic on each of those features. Then we have another group of features that we call competencies, and basically these are grades, but for exams and their competencies covered. So an exam can cover, for example, the reading competency. So we have a grade for the reading then. And we have also statistical features on each of those competencies feature, basically. So for instance, we have group average, we have the overall grade for competencies, we have standard deviation for the evaluation of the competencies, we have the number of evaluations for each competencies, we have the progression between the competencies, so is the student improving or regressing, and so on. And then we have variation features that are just the set of features comparing each terms together. So for variation features, we don't have them for terms 1, obviously, but we have them for terms 2 because they compared terms 1 with terms 2. So for instance, we could say that one of the variation features is variation in the French grade, for instance. So is the French grade 10 point higher or 10 point lower, and so on. So we have tons of variation features like this, comparing terms 1 and terms 2, and terms 2 and terms 3. And then the last sets of features are basically the targets feature. There's tons of them. I'm not going to talk about them, but these are all features related to the third terms. But in this research project, we actually used only the final grade as a letter. And well, we used some of those targets features as features to try to guess the final grade, but I'll come back on this a bit later in the presentation. So with the targets, we have 328 features, but basically without all the features related to the third terms, we have 270 features or less in each of our data sets that we used. Our goal in this specific research project is to predict the final grade. So we want to especially predict it as a letter in that case. We had to do some cleaning of these basic data set. So we remove all duplicate data that we had, but we also had to remove instances where there were missing data that were too important to be just ignored. However, other instances were kept with generic feelings, even though there were some missing data into them. Overall, after the cleaning and everything, we got a basic data set with 63,040 instances to work with. From these instances, we have 16,000 unique students, well, unique IDs, because we have no way of ensuring that each unique IDs are in fact unique students, but that gives you a broad idea of the data that we used for this project. So the first experiment that we did with this data set, and obviously, I'm just going to talk about the experiment that were interesting in this project because we did tons of testing with the various dataset that we created. But the most important one will be presented into 4 experiments here. So the first one is with the complete dataset, which was 270 feature plus the class chosen among the third terms feature. In that case, it was the prediction of the third term grades as letter. The class are quite imbalanced as expected, obviously. So we have 4,600 something grade A, more than 23,000 grade B, almost 18,000 grade C, and then we have little less grade D and only a few failing grades that are E. Keep in mind that it doesn't mean that the students didn't pass their year. So we did the testing for several algorithms. So KNN with 1NN and 5NN, C4.5, CART, naive Bayes, BaseNet, support vector machine, logistic regression, multi-layer perceptron, AdaBoost, bagging, random forest. Unsurprisingly, random forest, SVM are among the best algorithms. We were surprised to see, however, that AdaBoost only got 63% accuracy, and also that multi-layer perceptron could not get the same accuracy as random forests. In that case, all those tests were done using tenfold cross-validation, except for the multi-layer perceptron, because it was 12 hours per fold. We did it on CPU, so it was extremely long. But we even with split tests, all the other algorithms had the same results. So we can assume that we probably will not have improved much or decreased much the result of the MLP. For the second experiment, we actually decided to add a few information on the third terms, because we thought that maybe, well, you know, these results are not that good. We are only able to guess 74% of the grade of the final grade of student using both term 1 and term 2. So this we expected a bit better actually. So in that case, with this experiment, we did 5 variations. We only used random forest, which was the best one in the previous experiment. So the first variation, we added features about the absence of the student in the third terms, and this shed similar result. We actually had 74.6% accuracy, so very similar. It did not improve much our result. Then we also added the features about the competencies, which add up to 324 feature, and in that case we were able to get 76% accuracy. Then we added features about grades. With the features about the grade, we were able to have 82.77% accuracy. But obviously, if we had the grade of the subject for the classification, obviously it's much easier to guess the final grades, right? And in the fourth variation, we did variation number 2 and variation number 4. And then on variation 5, we added everything except the features that would allow deducing directly the final grades. And surprisingly, even though we added almost everything that we could find, we only obtained 82.76% accuracy, which is quite surprising because this is a 5-class problem, so we expected that we could reach at least 90%. But we might be into a case of curse of dimensionality here. So for the third experiment, we did some automatic improvement with feature selection and with also oversampling. So we used CFS subset eval and we didn't see much difference. Then we also used principal components analysis, and which got us 146 features, and random forest dropped to 64.6% accuracy, so it's actually very bad. Then we tried to improve the problem of class imbalance with SMOTE. We saw a slight improvement to 75% accuracy from 74.4. And surprisingly, we also used a top 100 info gain. So we only kept the top 100 feature rank with an info gain. And with SMOTE, we were able to obtain 75.3 accuracy, percent accuracy. Then we ran several times SMOTE on our dataset to see what happens if we decrease the imbalance, and we did not see any improvement from this. And obviously this is because SMOTE is actually best with low dimensional imbalance data. Then the fourth and last experiment, we decided to manually select the feature. So in the first feature set, we removed all the variation feature, In the second feature set, we did the same thing as feature set 1, minus all competencies, all absence. And what we find out with those two variations is that even though we removed a lot of feature, we kept about the same accuracy, so 74.6 and 75.15%. So we decided that we would try to decrease the accuracy purposely. So with the feature set number 3, we decided to remove the best feature with the top 100 info gain. So we ranked all the 270 feature with info gain, and we removed the top 100 feature. And actually, we were very surprised to see that we got 72.46% accuracy. So only a slight decrease, even though we removed all the best feature. And for feature set number 4, we also remove all grade and score related feature, and we remove all competencies and all variation features, including the aggregation features. And in that case, we only saw a decrease to 71.6% accuracy. So we decided to go a bit extreme, and so for feature set number 5, we only kept the features totally unrelated to the score. And we were still able to obtain 51.17% accuracy. However, we see that this is a bigger decrease, so we still need some features. So we see that there's redundancy in our feature, and that the algorithms are able to find those redundancies. So if we remove good feature, it still works, basically. So in conclusion, well, this is a bit underwhelming result for a 5-class problem, but that's because it's actually extremely difficult to predict the final grades of students. However, it's good to see that it's extremely robust as a classification, and we have very high generalization. So even though we remove tons of feature, it's still working very good, and we don't see a big decrease in the performance. We also know that the dataset is not very clean, or probably not completely accurate, but this is actually impossible to address. So thank you for your attention, and here are our main partner, and we have a paid position open if you're interested, or if you have students interested. Thank you.
Hello everyone, my name is Adrian Iordechioae and I am from Ștefan cel Mare University of Suceava. In the following moments, I will present you the paper entitled Aggregating Live Tags for Opportunistic Crowdsensing with Mobile and Smart Glasses Users. Mobile crowdsensing is a technique where a large group of individuals having mobile devices capable of sensing and computing collectively, share data and extract information to measure, map, analyze, estimate, or infer any processes of common interest. My presentation is structured in the following sections: Introduction, Live Tags, Extension of live tags for crowdsensing, User interface, Evaluation, Practical contributions, Conclusion. Introduction. In this work, we demonstrate the opportunity of a new concept by combining two existing technologies, live logging and mobile crowdsourcing. The outcome is an instance of opportunistic mobile crowdsensing where data collected by mobile and wearable camera devices is used to perform queries regarding everyday objects and concepts of interest. Our approach is to start from an existing prototype called Live Tags, originally designed for single-user operation, and show how it can be extended with cloud service towards multi-user opportunistic crowdsensing. We demonstrate the concept with a functional prototype for which we present engineering details and preliminary evaluation results, while we live in deep evaluation for future work. Live tags. Live tags is a wearable prototype designed to automatically capture snapshots using a camera glasses and to summarize life with word clouds. Live tags focuses on the concept of abstracting life by providing users with executive summaries of what their visual experience were like, as recorded from the first person, eye-level perspective of the Smartglasses rather than with a list of snapshots and videos as in conventional life logging applications. In the figure 2, you can see an example of two snapshots captured by live tags in the park scenario and tag cloud generated. Using live tags, life experiences are stored for future consultation. Users can also choose to select synthetic path of the life log, a cloud of concepts, to share data on social network without affecting the privacy of bystanders. Snapshots are captured using an Android application on a smartphone and are periodically uploaded to a desktop PC, for where they are sent to clarify a computer vision API for extracting concepts. Extension of live tags for crowdsensing. To extend the functionality of live tags and implement our concept, we designed a mobile crowdsensing system to foster community queries about objects of interest. Our system falls into the category of opportunistic mobile systems because live logs can be captured passively. The user only needs to set the frequency with which the snapshots are captured and search object, and then the system works independently. In figure 4 is an example of snapshot captured by our mobile and wearable crowdsensing system in university building. The software architecture of our system consists of a server, a backend component, and the user interface. On the client side, we employ standard web technology such as HTML, CSS, JavaScript, the Google Maps library, the Firebase real-time database, and the Firebase cloud storage. The Firebase real-time database is used to share query-related information. User X is looking for object Y between many crowdsensing workers in real time. We used the Firebase cloud storage to implement high scalability storage for the image automatically captured by the crowdsensing devices when the specified objects were identified. The client runs in a web browser captured images and stores them into the Firebase cloud storage, from where they are processed by the Google Cloud Vision API, and the response is saved in the Firebase database as a list of objects with corresponding GPS coordinates. In figure 6, you can see our application detecting oranges in supermarket. The Google Maps SDK was employed to display the location where a specific object was found via the geolocation functionality available in modern web browsers. Functions for Firebase is responsible for the management of the queries, sending video frames from crowdsensing workers to the Google Cloud Vision API, parsing the result and returning matches to the client that generated the request. In figure 8, it's presented the block diagram for our opportunistic mobile and wearable crowdsensing system. The client side of the application runs in the browser, the device having an internet connection and access to an internal or external video camera. The snapshots captured from video camera are sent to Firebase storage. The routes where was stored images consist of user ID, and the timestamps are used by a Firebase function to post images to Google Vision API. Google Vision API processes the image and detects the objects. In Firebase database are stored each users with all own routes images, timestamps, and location coordinates. If an object searched by an user is found, that user will receive a notification. User interface. User application interface is intuitive and easy to use. When accessing the application, the user is asked for permission to access the camera and the location of the device. If the user wants to use an external device with a built-in camera, such as a pair of smart glasses, he must connect this external device to the hotspot of the smartphone and specify the URL of the video stream. In Figure 9 is presented user interface before start object detection process. The Detect Object button starts searching for the object entered in the text field. By pressing the More Details button, the user will be able to see the result obtaining after the image processing by the Google Cloud Vision API. In the lower left corner of the user interface, there is another button. It displays the application in full screen mode. In Figure 10, it's presented the application detects object other than searched by the user. User search for object cup, but the application detects object like sunglasses, bottle, computer keyboard, or tableware. When searching for an object, if it is found, a red border appears with the name of the object inside according to the figure on the right, where a bench was detected. These colors can be changed by the programmer according to his preference. When you press the More Details button, a list of up to 20 labels of detected objects sorted in descending order according to accuracy and object to which the location can be provided. If the searched object is found by another user, a notification appears in the right corner of the user interface, and the location of the object is shown on a map in Google Maps. For example, in Figure 12 is presented application searched for object mug, and the user was notified that another user found it. After a click on notification, the user can see a snapshot with object detected. Additionally, the user can see the location of object detected, like in Figure 13. Evaluation. We performed a preliminary evaluation of our system using the DelveTools panel from Google Chrome. Figure 14 shows results regarding the upload time of images to the Firebase storage less than 1 second, while receiving results from the Google Cloud Vision API takes less than 1 second as well. Of course, request response time are influenced by the speed of the internet connection, the available bandwidth, and the size of the data that is transmitted. We monitored the performance with up to 20 users simulated in the web browser to see how the application responds. Our preliminary results showed that the average request response time did not exceed 1 second. Our practical contributions. We introduced the idea of using live logging applications to implement queries about objects of interest from everyday life that could be answered in real time by means of opportunistic crowdsensing implemented with video camera-based devices. We describe an implementation of our concept by starting from the live tag system, which we extend with cloud resources and services, the Firebase real-time database, Firebase cloud storage, Google Cloud Vision API, and the Node.js application. In our prototype, the tag clouds of many users are queried from potential matches of objects and concepts of interest. We present preliminary results about our system and conclude with implications for future integration of live logging, mobile and wearable computing, and mobile crowd-sensing. Conclusion. We showed how a mobile crowd-sensing system could be implemented as the evolution of a live abstracting system, live tags, towards crowdsourcing queries and identification of objects and concepts of interest inside the community and addressing practical aspects from scaling single-user applications to multi-user systems. It is interesting to look at the implication of the concepts that we demonstrated. On one hand, we present an alternative use for live log data, converting it from a private resource to a public one for the benefit of the community. This perspective enables bystanders, which are regularly impacted negatively by video recording cameras in public places, to benefit from data collected by users of mobile and wearable camera devices. On the other hand, we showed how mobile crowd-sensing can employ large amounts of data collected by live logging enthusiasts for the purpose of increases the performance of crowd workers. We believe that further investigation of the connections and mutual benefits resulting from integrated live logging and mobile and wearable crowd-sensing technology will relieve new opportunities for new applications. Thank you for your attention.
In this short presentation, I will present you alternative deep learning architectures that perform data fusion, more specifically feature-level fusion in the context of human activity recognition. In this presentation, I will introduce you the context, then the related work, then the mobile health dataset, the deep learning architectures, the results and discussion, conclusion, and the references. Human activity recognition is a complex task to perform, but also a very popular mission for academic research. Recognizing activities is presented as one solution to face the problem of population aging, which involves a larger proportion of seniors and a lack of human resources. Also, it is often difficult for senior family members to aid or visit them due to the job location in different cities, for example. One solution to overcome this problem is to monitor routines and activities of daily living. How? In an automatic way. To do so, homes and apartments must be equipped with multiple sensors, collecting continuously raw data from these ones in the senior environment and seniors' movement. The raw data must be exploited and processed in order to develop efficient classification and/or prediction models with the help of machine or deep learning algorithms. Actually, the association between in-home sensors and artificial intelligence is referred as the paradigm called ambient intelligence. However, producing accurate classification or prediction models is the most challenging part of HAR. Indeed, with the rapid development of sensing technologies, multiple sensors can be integrated into environment or devices, leading to a complex set of raw data to exploit. Each data source can provide specific information, allowing to discriminate more accurately between activities when data are correctly fused together. On the contrary, when information is incorrectly combined, classification or prediction performances decrease and sometimes significantly. The field of research that deals with multiple sensors is called data fusion or information fusion. Actually, data fusion is an old paradigm that emerged between the 70s and the 80s to develop military applications. The purpose of this paradigm is to combine data collected from multiple sensors to achieve better performances than a single sensor. Lately, data fusion becomes more and more popular in the domain of activity recognition. Now we know three levels: the data level fusion, feature level fusion, and decision level fusion. In data level fusion, the idea is to merge different data sources with the aim of generating new raw data being more informative and synthetic than the original sources. The existing method allowing to perform data level fusion are the weighted average and the least square method, Kalman filter, Dempster-Shafer theory, and other. However, the main limitation of this fusion level is that the number of data sources are limited. Indeed, the greater the number of data sources is, the less informative and synthetic the new raw data is, which reduces the sets of the different activities that can be recognized effectively. Feature level fusion is an excellent way to combine heterogeneous sensor data and is also the most encountered strategy in HAR. In this case, features are extracted from raw data collected by each source independently and then combined by using machine or deep learning algorithm. The third level, which is a decision level fusion, entails merging individual classifier decision to reach a unique classification by using classical inference, ensemble boosting, or Bayesian inference. As this paper deals with feature level fusion, the related work will be focused on this specific category. Feature level fusion has the purpose of extracting sets of features from multiple data sources. Once features are extracted, they are combined using machine learning algorithm or deep learning algorithm. Hence, it is possible to divide feature level fusion into two subcategories, which are uncrafted feature fusion and deep learning fusion. Uncrafted features fusion mainly concern time series provided by sensors. The first step is to segment time series with the use of a fixed or varied time window length. The time window slides over the time series with or without an overlap between two successive windows. From each window, time domain, frequency domain, or time frequency domain features are computed. However, extracting many of its features creates high-dimensional vector of features. The main problem with high-dimensional vector is the risk that data become very sparse, leading to overfitted classification models. This problem is referred as the curse of dimensionality. Consequently, the solution to overcome this curse is to reduce the dimensionality with some method like the principal component analysis, extremely randomized tree, and other. For example, Ambient et al. Showed that the precision of the recognition of 6 activities increased from 90% to 94% with this data fusion. However, the main limitation of this category is the difficulty to include data sources other than time series to construct more complete classification model. Over the last years, deep learning algorithms have been widely used for the task of HIR. On the contrary of handcrafted features, which sometimes requires the involvement of experts, deep learning-based fusion can work with raw data, where the feature extraction can be very complex due to the richness of information. For example, Quinn et al. Proposed a fusion ResNet framework. They transformed time series into visual images with 2 methods, and they obtained 93% of good classification. Despite the fact that deep learning method seems to be the perfect solution for data fusion, the literature, to the best of knowledge, does not investigate the possibility to fuse raw data and extracted statistical feature within a unique deep learning model. This is exactly the aim of this presentation. The mobile health dataset is exploited to assess the efficiency of the 2 proposed architectures of deep learning model for data fusion. This dataset is composed of 12 activities, where each activity has been performed by 10 subjects, and the duration of each activity is 1 minute, and they have been done 20 times. And the data have been acquired at a sampling rate of 50 Hz. There are different sensors, but we exploited only 2 sensors. Actually, it was 2 accelerometers based on the chest, located on the chest and the left ankle. The proposed architectures in the following slides rely on convolutional neural network. So the statistical features that we used belong to the time domain and are very popular. These features are computed from a time windows of length of 1 second defined for each time series. In this study, features are extracted for the 3 axes X, Y, and Z of the accelerometer located at the left ankle. Here is a list of the feature extracted: minimum, maximum, mean, standard deviation, skewness, kurtosis, mean absolute deviation, waveform length, mean crossing rate, and energy. Finally, by extracting these 10 features for each axis of the accelerometers, we obtain a total of 30 features per instance. The first architecture that we considered for result comparison is a classical CNN. The inputs are time series provided by the accelerometers, and more precisely, an input is composed of 3 axes X, Y, and Z. Thus, in this study, the shape of input is 50 by 6, 50 samples per time windows, and 6 time series. Regarding the CNN, its architecture is composed of 2 parts, which are the convolutional part, so the convolution for feature extraction, and a typical multi-layer perceptron. The former is constructed by stacking convolutional layer, and we decided to stack 2 convolutional layers followed by a max pooling operation. We selected the rectified linear unit, the ReLU, as activation function. We also added, after each convolutional layer, a dropout that randomly sets 25% of inputs units to 0 at each update during the training process. The objective of the dropout is to prevent overfitting. The other detail for people who are interested are given in the paper. The second reference architecture of deep learning that we exploited for data fusion is different. Indeed, we split the inputs into two distinct sources of information according to the location of the accelerometers. Compared to the first architecture described just previously, we did not change the architecture and the setting of parameter. However, there are two main differences, which are the feature level fusion. After that, we flatten each output of the two independent max pooling operation and the number of extracted values after convolution. This architecture has the advantage of accepting different sources of data, like image with time series, and processing them differently. The proposed architectures are similar to the second model, R82, used as a reference in the sense that we have the same input A, and input B. However, the main difference between R82 and the proposed here is the process of extracting features. Indeed, features of input A are determined from the same stacked convolutional layers than R82, while both of input B are statistical features discussed previously. This figure shows the first proposed architecture PA1 for data fusion. Also, it should be mentioned that the settings are identical to RA2 and RA1. The other change with this architecture is that we have fewer features after the fusion than RA2. In this case, we have 190 features instead of 320 for RA2. This imbalance is the extracted feature between A and B and can lead to lower classification performance. This is the reason why we propose a second deep learning algorithm for data fusion here. So here, we decided to reduce the number of features extracted from the convolutional part by adding a layer of neuron after the max pooling operation. This layer of neurons has no activation function and acts like a principal component analysis method attempting to correlate variables together and reduce the dimensionality of the output space. We compared the influence of this layer on classification performances by defining the number of neurons to 150. Additionally, as you can see in the red dotted line in the box, the successive layers of convolution followed by the max pooling layer and the layer of neurons form a kind of encoder called a convolutional autoencoder. So we use the accuracy and the coherence kappa as metric to compare results. Each model has been trained according to the leave one subject out strategy, which means that we used data of one subject to test models and all other subjects have been exploited to train models. Also, according to the stochastic phenomenon in the training stage due to optimization algorithm, we run 10 times the training and testing stage on each created dataset for each model. Here, the figure shows the performances of each model, which are the averages of accuracies versus the subject who was left out. As we can see, averages of accuracy vary from 0.67 for PA2 100 and 0.94 for PA2 100. More specifically, each architecture follows approximately the same variation except on a few subjects. Results related to coherence kappa are similar. Thus, any model can be defined as the best model with these results, which confirms that the proposed architecture can be a very interesting alternative. However, the proposed architecture have better overall performances since the mean of the average of accuracy are 0.84 0.84 and 0.84 for PA1, PA2 100, and PA2 50. Whereas Array 1 and Array 2 have only 0.83 and 0.83. Nevertheless, the results of the proposed architecture are encouraging because we extract only a few and simple time domain features. Next, we focused on the maximum accuracy value over the 10 runs for each model versus the subject who was left out. This figure shows the result, and once again, any architecture can be defined as the best model. The reason explaining this conclusion are twofold. First, the number of parameters to optimize for Array 2 is higher, increasing the quality and the quantity of extracted features. Second, the reduction of the number of features provided by convolutional layer, which merge harmoniously with the number of statistical methods. So, the objective of this study was to propose alternative deep learning architecture for data fusion in the context of HAR. Hence, we introduce models that fuse statistical features and features extracted from convolutional layer. To do that, we exploited the M-Health dataset to compare reference and propose architectures. The results are very satisfactory because we computed a low number of simple time domain features, and according to the results, the model that we recommend are Array 2 and PA2, 50 or more generally PA2 if the number of features extracted from convolutional layer is approximately equal to the number of statistical features. And first, we have some future work. Like, we must evaluate the proposed architecture with other datasets. Secondly, it should be interesting to optimize the hyperparameter of the deep learning models. And in overall, we are delighted to present you this promising work in the domain of data fusion for HAR. Here are the references. Thank you.
Welcome everyone. My name is Cédric de Montgivert and I am a student of the Laboratoire d'intelligence ambiante pour la reconnaissance d'activité at the Université du Québec à Chicoutimi. For the next 15 minutes, I will give you an overview of our last paper entitled Fuzzy Features for Quality Estimation of Activity Instances in a Dataset, a paper written with my directors and in collaboration with the Domus Laboratory of the Sherbrooke University. So, let's begin this talk by introducing the context. For my thesis, I'm trying to solve a part of a larger collaborative project in which we intend to allow heterogeneous smart environments like smart homes, laboratory facilities, and software simulations to communicate with distant clinics. The long-term goal of this project is to help clinicians to remotely monitor the health state of multiple patients with degenerative disease by using dashboards built with statistics about their day-to-day activities. The overall process goes as is. Each smart environment publishes on their own a chosen set of sensors to a distant platform that store, transform, and propagate them in the form of various time series. Client applications can then request the resulting information via a specific API that communicate with the underlying platform. This project leads to various problems that make activity recognition more challenging than usual. Firstly, we have to deal with the heterogeneity of each installation that can vary in nature, layout, purpose, and equipment. As a result, we need algorithms that can generalize well to multiple situations. We also lack of training data, as extracting logs from a careful observation of 4 dozen installations is costly in resource. Consequently, we can easily retrain existing learning algorithms for activity recognition to adapt them to each installed environment. Finally, we want to deliver more information than just the beginning and the termination of a specific activity. Extracting the quality of each activity instance, for example, may be useful for us in order to establish the evolution of the health state of an inhabitant, notably because the complexity of each executed activity follows the cognitive capabilities of a patient. So the question is, how can we estimate the quality in this context? Our approach to solving this problem is based on fuzzy logic, and our method heavily uses fuzzy sets in order to represent various features of different activities. Fuzzy sets are mathematical objects derived from classical set theory. In a more explicit way, if we take any set A, we can, for any subset B of A, define a function CB over A in such a way that CB evaluates to 1 if and only if it receives the element that belongs to B. This resulting function, that evaluates to 0 in any other case, is called the characteristic function of B over A. In fuzzy logic, a fuzzy set is a set defined by a similar function, called a membership function, that can assign any real value between 0 and 1 to an element of A. Such a value, called a membership degree, estimates the strength of the relationship between the given element and the described set. So, what can we describe with fuzzy sets? In fact, given a timeline, we can use them in order to represent qualitative features related to a set of instances of this timeline. For that purpose, we can define multiple membership functions that will act as some sort of standardization layer between our environments and our algorithms. For example, we can easily represent the relationship between a time area and each different moment of a day by defining fuzzy sets for midnight, morning, midday, afternoon, and evening instance. This feature is helpful as some activities like cooking are strongly related to the specific moment of a day. As activities may trigger sensors of various nature, it's possible to represent the number of unique sensor types activated during a given time area by using fuzzy sets that represent instances with rich, average, and poor sensor variety. In order to discriminate activities that require to move or use different furniture more frequently, we can also define fuzzy sets of instances with silent, noisy, or turbulent sensor activity. The duration of a time area is also a good indicator for discriminating fast activities from slow ones, and in order to modeling this kind of information, we can use fuzzy sets of short, average, long, extensive, or infinite durations. Finally, as activities are more related to different locations, like a bedroom for a sleeping activity or a bathroom for the action of taking a shower, we can modelize the relationship between a time area and each different type of room with fuzzy sets of kitchen, bathroom, living, bedroom, or outdoor-related instance. These qualitative fuzzy features will allow us to develop more generalizable algorithms that are less subject to quantitative information variations due to the number of sensors, the time zone, or the layout of each environment. Examples of membership functions for each of these features are described in the paper. I do not include them in this presentation due to time restriction matter. In the previous slide, we looked at which features can be used for describing a given period of time. Now, let's see how we can use these features in order to estimate the overall quality of an activity label. In order to illustrate this, let's imagine that we have a time area that is described by both a sensor activity and a duration. As a result, if this time area captures the realization of a cooking activity, we would like to know its overall quality. For that purpose, we propose to use sets of fuzzy rules. The solution is already used in domains like robotics for deriving the membership degree of an element to an outgoing fuzzy set by using ingoing membership degrees to other ones. Each fuzzy rules express the relationship between each features of a time area and the resulting quality of the outgoing activity. In this example, we have rules that express that long and turbulent time areas make reliable cooking activities, and noisy but short ones makes more ambiguous instances. To compute each resulting quality, we have to carry forward each relationship degree to each rule antecedent. Then, with this information, we can compute the conjunction of each ingoing membership degree as the membership degree to each rule's consequent. For computing this conjunction, we can use many fuzzy operators. In this example, and in our paper, we used the product of each ingoing membership degree. The final result by outgoing fuzzy set is then the union of each consequent membership degree of each rule in the table. This result can be obtained via a fuzzy disjunction operator that is, in this example and in our paper, just an addition of each value. In our paper, we applied the described method for analyzing the labels of the Aruba dataset of CASAS. We made sets of fuzzy rules for assessing the quality of 5 distinct activities that are sleeping, bed to toilet, relax, meal preparation, and eating. You can look at each rule set via the article. To analyze Aruba, we first computed the quality of each label of the dataset. With the resulting membership degree, we extracted different statistics like quartiles, averages, minimums, maximums, and correlations. We also reduced each quality to a unique score by computing a dot product between a vector of membership degree and a ponderation vector as described at the beginning of this slide. Finally, we summarized the results in different dashboards for helping us to get an overview of the dataset strengths and weaknesses. As a result, we can see that some activities do not fit with our rules, and the meal preparation activity is the one that gets the worst quality score with an average membership degree to the irregular fuzzy set of 92.7%. I will focus on the analysis of this activity for the rest of this presentation. In order to discover the nature of the difference between what we expected of a meal preparation activity and what was annotated in the Aruba dataset, we tried to make a profile of a typical cooking activity. For that, we filtered our 1,600 labels in order to keep only the ones that achieved an overall quality score lesser than 50%. We then computed different statistics for each fuzzy features that we described at the beginning of this presentation. To summarize, the Aruba dataset displays mostly meal preparation activities that occurs at the morning, midday, afternoon, or the evening. These activities was also mostly fast or short and activate a lot of movement sensors. Finally, the overall variety of each activity is poor, mostly because the Aruba dataset does not contain any information about the use of furnitures. Following our rules, the variety is a problem, but not a problem that justifies an average membership degree of 92.7% to the irregular quality fuzzy set. The real subject here is more about the duration of each cooking activity that mostly represents the preparation of ready-to-cook dishes instead of more complex ones. Some meal preparation labels are also split in multiple parts, but they are in such a minority that their correction does not impact the overall result. The analysis of other activities, such as the eating activity, also support the thesis of a short cooking session. To conclude, we presented a method for assessing the quality of different activity labels by using fuzzy logic. The described solution answered to 3 problems caused by our context of research. The first one was about the heterogeneity of for smart environments. We handled this problematic by defining membership functions to generate fuzzy features in such a way that we have to work with only qualitative information that is not subject to variation. We also solved the second problem, that was about the lack of training data by using handmade or generated rule sets applicable to all environments without training. At least, we answered to the need of displaying more information about activities by using time series of membership degrees to various concepts instead of labels that only modelize the beginning and the termination of an activity. Finally, at the end of our article, we applied our method on a dataset of casas and explained how we were able to extract information about each label with our method. If you have any questions, I will be pleased to answer them by email. And if you want to have more information about our work, I also invite you to read our article that presents elements that were not covered by this presentation. And thank you for your time.
So, welcome everyone. My name is Giulia Zampetri, and today I'm going to present you our paper Active Human Agency in Artificial Intelligence Mediation. So, first of all, the outline of my presentation today. In the first part, introduction, I will outline the main purpose of the paper and the rationale behind it. While in the second part, I will present the theoretical framework of mediation and human agents by Nicholas Carnam. And then in the third part, I will describe the state of the art of AI in 2020 based on Carnam's framework. Moreover, I will present the proposed concepts of passive and active human agency and emphasize the importance of individual AI redress. To conclude, I'm going to combine the theories presented in the first and second part to ask why it is important to look again at Carnam's framework and what his interpretation of human agency in 2020 and beyond may entail. So, scholars across disciplines raised questions and concerns about the notion of human intervention, control, and oversight over artificial intelligence systems. This observation becomes especially relevant given the development and spread of ubiquitous computing and increasing adoption of AI in everyday technological infrastructure. So our paper proposes a conceptual interpretation and future research agenda for the concept of human agency. The key theoretical critique of this paper is that advanced and ubiquitous AI systems enjoy unprecedented authority. Adapting the theoretical framework of mediation developed by Nicholas Carnam in 2000, the paper questions technological authority and human agency in 2020. Ultimately, we propose a distinction between passive and active human agency and argue to empower active human agency. We emphasize now redress option could augment active human agency and call for theoretical and empirical research on individual AI redress. But first of all, it's important to define what actually human agency means. And human agency, according to the definition provided by the European Commission High-Level Expert Group on AI, is the ability of users to make informed autonomous decisions regarding AI systems. Users should have tools and knowledge in order to self-assess or challenge the system. At the same time, AI systems should support individuals in making better, more informed choices in accordance with their goals. So in this first section of the paper, I'm going to analyze Gardner's framework of mediation. In his theory, Gardner defines mediation as the mediated interconnection that is part of the infrastructure of most people's lives in the internet age. And Gardner differentiates three types of mediation involving different entities. So the first type of mediation is mediation by other human agents. So in this case, people themselves are mediators, for example, journalists as gatekeepers. The second type of mediation is systems of symbolic representation, which concerns how humans produce meaning encode, and consume, meaning decode, text, and how the meaning of this content changes across cultures and languages. The third type refers to mediation by means of technological tools, both between humans and nature and between humans themselves. So, in Gardner's framework, we focus on the role of human agents, which help us to examine the concept of human agency in mediation. So, to better explain this concept, we use the example of the radio. So radio devices both mediate and disseminate information, thereby inducing hierarchical mediation structures. The user is always actively aware of the hierarchical relations and can actively modify or alter the artifact. For example, by painting in the radio, or for example, by putting the radio underwater in order to destroy it. What the technical artifact is used for, and how it might serve requirements in the future, is to be determined by users in the first place. So the ownership also includes options to challenge the technical artifact in case of malfunctions. Considering the radio, then users were contacting the manufacturer where they purchased the apparatus and filed an error to receive, for example, a replacement. So to quickly sum up Gardner's theoretical framework, active human agency is present and enables effective remedies for user in case of deficiency or harm being done by technology. So humans have agency in every kind of mediation process through technological tools, system of symbolic representation, as well as between humans themselves. This section constitutes the main part of our paper and outline how new development of AI technology lead us to reconsider Gardner's framework. So to elaborate, we look at EU policy on AI and human agency. Then we frame the concept of human agency by differentiating between passive and active human agency. And in the end, we further operationalize active human agency, and we discuss the notion of redress to highlight the need for accessible active human agency. In this part, we analyze human agency in the context of European policy on AI. And there are two main policy documents that mention human agency. So the first one is the EAI Trustworthy AI Framework, published in 2019. And the EAI in listing the 7 key requirements for trustworthy AI highlights the central role of human agency in preserving human autonomy throughout the AI decision-making process and of human oversight in ensuring that AI systems do not threaten human autonomy or cause undesired consequences. So human agency allows users to interact and take informed decision, having the knowledge and tools to understand and interact with the AI systems. However, the document misses to specifically explain how the principle of human agency and oversight should be operationalized in the EU. Earlier this year, the European Commission published the white paper on AI. So this is the second document talking at European level addressing human agency. And the document points out three kind of risks associated with AI systems. And the first one is information selection and content moderation by online intermediaries, the tracing of people's daily habits, and third, creating information asymmetries. All three characteristics of AI systems could lead to a situation in which citizens might be left powerless. Therefore, the nature of AI systems could already challenge human agency by the design of the system themselves. To summarize, what we find out about by looking at European policy documents is that the concept of human agency is not yet sufficiently explained. I will now continue with the proposed concept of passive human agency, which will bring me then to the concept of active human agency. So, as laid out by the European Union's AI policy documents, the increasing complexity, autonomy, and ubiquity of AI system can result in a more disempowered form of humans involved in AI. In order to frame the concept of passive human agency, we connect to the concept of human out of the loop and human on the loop. Human out of the loop describes a state in which human agents are largely excluded from AI-driven operations. So such human agents do not have any oversight in the form of options during the decision-making process. So, as a result, the system is in full control. The concept of human on the loop describes a state in which human agents take a more significant control, but still not an active role. So human agents monitor and supervise the AI system and can, if necessary, intervene, but it's not a proper active role, as we're going to see later. So, as AI technology are characterized by complex technological infrastructure, there is no unified process or system in place to explain and communicate these risks to users. So human agency is significantly decreased because appropriate, unanimous, and understandable explanation of features, consequences, and wider risks deriving from AI mediation are lacking. Decreasing human agency eventually diminishes the overall user agency in AI mediation. So coming back to Garnham's concept of mediation, also content is an integral part. So the mediation through the content includes the production, distribution, and consumption of content. So the increasing exclusion of humans in the mediation process and a lack of technological literacy by users regarding AI systems restricts human agency. So the lack of human involvement can also result in a misconduction of meaning, as the AI system can independently encode a message and human decode it. So to better illustrate passive human agency, we use the example of communicative robots. So communicative robots often rely on AI systems and can be found in our everyday life, in the form, for example, of smart speakers, social bots on social media, or work bots, like the one that generate journalistic content. Humans interact with technological tools, such as this kind of robot, but their agency is challenged in various ways. We identify three main challenges. The first one is that users can be unaware of communicating with an automated AI system or distinguish if the content was human or AI generated. Secondly, the source of the content can be unknown or hard to verify. And the third challenge is that users may have difficulties in recognizing if the AI system provides trustworthy content. So, in contrast to the previous example of the radio, users have rather restricted means to consciously redress the AI mediation to an independent authority to claim remedy in case harm was done. So, in contrast to passive human agency, multiple scholars emphasize the integral role of humans in relation to contextualizing the role of AI. So, active human agency can be related to the concepts of human in the loop and human in command. And these concepts are seen as opposed to the earlier mentioned concept of human out of the loop and human on the loop. So in the case of active human agency, we can refer to human in the loop, which concept suggests that human agents are actively involved and retain full control over decisions taken by AI systems. So AI systems take an assisting function, such as providing recommendation instead of operating fully independently. Also, the concept of human in command represents well the concept of human agency, and human in command is basically the capability to oversee the overall activity of the AI system, including its broader economic, societal, legal, and ethical impact, and also represent the ability to decide when and how to use the AI system in any particular situation. So basically, to sum up, human agents represent crucial actors throughout the AI operating process, such as in designing and programming, providing input, monitoring the process, and using the output. Subsequently, AI systems' output remain comprehensible and traceable for user, enabling an active form of agency. So, we suggest augmenting active human agency through redress. So to date, we have little research focusing on how user can actively challenge a decision or an outcome of an AI system. We introduced the concept of AI redress as a way to operationalize active human agency and hence to empower users. So the concept of individual redress in relation to AI system has been mentioned in several AI reports. However, the concept and operationalization are not yet truly explored, neither in a scientific literature nor in an AI policy-related framework. So it's important to define what actually redress is. So in the policy framework on AI, the concept of redress appears in the EU EAI Trustworthy AI guidelines, which I mentioned already before, and suggests providing accessible mechanisms that ensure adequate redress, which is key to ensure trust. Particular attention should be paid to vulnerable persons or groups. So based on the research and the framework of active and passive human agency, we suggest three key elements to enable active redress mechanism for users. Number one, comprehensive and unbiased information on AI interaction. Number two, the right to contact with a human. And number three, timely and effective remedies for negatively affected users. So to conclude my presentation, hidden data capture based on the ubiquitous and invisible AI infrastructure challenged the notion of human agency in mediation to a fundamental extent. So as we show throughout our paper and today in my presentation, the concept of human agency itself is not sufficiently well understood. This paper investigate and frame the concept of human agency, and we pointed out that the era of ubiquitous AI reinforced a passive form of human agency. So this calls for the need to develop systematic approaches for investigating the positive pathways for users to retain or move forward towards active human agency. A possible way to approach this empowering and socially responsible form of human-machine interaction could be by means of the redress. Here you can find the references we used to develop our paper. And in case you have any questions and feedback, don't hesitate to reach out to us. We will be more than happy to receive feedback as well as to answer questions. And thank you for your attention. I hope this presentation sparked your interest in reading our paper. Thank you.
Hello, my name is Simon Flutura from the University of Augsburg, and I'm gonna present the paper Interactive Machine Learning and Explainability in Mobile Classification of Forest Aesthetics. Forests have the potential to increase personal well-being in various ways. This goes so far that the mere view of a natural setting in front of the window or images have an effect. Nonetheless, there are individual preferences in the taste of aesthetics that motivate us to generate personalized models of aesthetics. Moreover, we want to explore the possibility to improve mobile interactive machine learning using visual explanations. Photographs taken by experts tend to focus on other aspects of scenery than photos taken by visitors. Visitor-employed photography is an established method where the average visitor are given cameras to capture their point of view. This methodology is chosen by us as the basis of our dataset. Scenic beauty has played a role in research of human-computer interaction, mostly in route planning for road trips. The work relies on readily available datasets of Google Street View usually. Since forests are best viewed from smaller paths, they are mostly absent in HDI research to date. In the following, we present an overview on our mobile app for interactive machine learning. On the home screen, the first screen to the left, the user is able to select a data collection, retrain a model, or restore a model, and recognize a picture. Next, the collection screen allows collections to be managed, to add collections or to delete collections. Classes can be added and pictures can be added to the selected collection. On the back-end side of our application, TensorFlow and similar tools for machine learning do not run on Android to a full extent out of the box. Therefore, our approach relies on a CH root environment where a GNU Linux runs virtualized atop of Android. On this screen, you see rescaled images as they are used in our training process. An aesthetic labeled path can be seen on the left image, whereas the images to the right are labeled as unaesthetic due to human intervention. The data collection of 202 images was created by geography students. To create a plausible dataset, one student checked the images for coherence and balance. Here you can see the image of a street sign on the left and the saliency map of the image generated by deep Taylor decomposition on the right. It is clear to see that the activation of the neural network is focused on the street sign. Machine learning models per se are black boxes extracted automatically from data and hard to understand even for experts. With explainable AI, we want the user to get a better grasp on the structure of the model and to help the user to shape the model by himself. Therefore, deep Taylor decomposition for saliency map generation is chosen. On our example dataset, doing image retraining over MobileNet version 2, we achieved 79.9% accuracy in classifying forest aesthetics. This is not an easy problem, and thus the results are promising on such a small dataset. Based on our dataset, the mobile app and the deep tailor decomposition, we evaluated the benefit of adding an explainable AI solution to our mobile application. This was done via an online study with 31 participants, whereof 13 were female and 18 were male. They had a self-assigned score of 2.48 points out of 5 regarding their machine learning knowledge. Participants were evenly and randomly assigned to two groups, where the group A did get a prototype presented with the XAI solution, and the group B a prototype without the XAI solution. Both groups were equally agreeing with the system classification results. XAI thus helped the user to sharpen his view regarding the features of aesthetic within forests, and XAI also helped to understand the system significantly better. Conclusively, XAI in our case helps to comprehend the decision of the system. Moreover, XAI contributes to the user's perception in sharpening his view regarding features of forest aesthetics. More work is required to communicate the mechanism of the training process to the user, and thus help the user to select the right samples to add to the model. Since in our case only people with higher level of machine learning knowledge were able to answer the respective question properly.
Hello everyone, I am Poonam Rajput, MTech Research Associate from IIT Hyderabad, and today we are going to discuss our work on detecting usage of mobile phones using deep learning technique done under the supervision of Dr. Sparsh Mittal, who is a professor in IIT Roorkee, and Shubhrajit Nag, who is a PhD research scholar in IIT Hyderabad. We all are well aware of the fact that mobile usage is rising fast. More than 50% of the video streaming requests and website traffic worldwide originates from the mobile. Time spent on mobile internet access is likely to surpass soon that being spent on televisions. The total number of apps available in major app stores has exceeded 5.5 million, with many of them being gaming apps. Also, active mobile social media users surpassed 3.46 billion. Smartphones can do many things: image or video or audio recording, computation, storage, and remaining functions over cloud. Plus, it has small form factor, low price, and wide availability. Along with this, smartphone has become a powerful yet insidious instrument for executing malicious acts. The distraction caused due to usage of mobile phones during driving is one of the major factors behind the increasing number of road accidents. So we can say that mobile addiction is a kind of serious problem. There is a need for devising some detection mechanism for mobile phone usage, which can help us in monitoring the usage pattern and avoiding indiscriminate and harmful usage. But manual detection of mobile usage is neither cost effective nor scalable. So we propose use of convolution neural network for detecting mobile phone usage, as CNNs are the backbone of well-known object detection algorithms. We believe that or technique for the detection of mobile phone usage can be very helpful for parents, lawmakers, and other leaders. There are many scenarios where our technique can be applied. We've broadly categorized them as follows. So, in homes, educational institutes, and workplaces, we can prevent excess or untimely usage of the mobile phone that will help us in improving productivity. People using mobile phone while performing crucial activities such as driving and giving a medical treatment can be monitored and alerted to avoid any accident. Similarly, older adults in assisted living scenarios can also be monitored. Mobile phone can be used for spying and data breach. Also, mobile phones may be prohibited in places such as exam halls, company meeting rooms, theaters, government places, court of laws. Similarly, mobile phones may allow the prisoners to commit new crimes inside the jail. Further, with the proliferation of mobile payments, many financial transactions now happen on mobile phones, and hence loss of mobile phone can have a severe impact on an individual. Thus, our technique can help in detecting misuse or theft of mobile phones. So we can produce evidence of law violation using our techniques. So in order to use deep learning algorithms for mobile detection, we come across various challenges. So one of the major challenges is non-availability of properly annotated dataset. As neural network models requires a massive amount of training data to make robust predictions, the lack of properly annotated dataset containing a sufficient number of images or videos of people using mobile phones is a major challenge. Our goal in this work is not merely detect or presence of a mobile phone and a person, but to also detect whether the mobile phone is being used by the person. For example, in an image where both a mobile phone and a person are present, the mobile phone may not be used by the person, hence individual or separate detection of a mobile phone and a person is not enough. Mobile phone is a comparatively small object when seen in photos or videos using surveillance or CCTV cameras. As a result, some of the existing object detection algorithms fail to detect it properly. As mobile phones have rapidly evolved from feature phones to smartphones, their size and appearance have changed drastically, making their detection challenging. So now we discuss our contribution in this work. So first thing that we have done is we create dataset. So we create two datasets which represent mobile phone usage in diverse scenarios. As we all know that collecting datasets has been the most challenging aspect when we want to apply deep learning on real-time or novel applications. So we create dataset, we have released our datasets and pre-trained deep learning models in public on this site. You can check out this site. So the first dataset we focused on is the Kaggle driver dataset, and this is a subset of State Farm distracted driver detection dataset on Kaggle. Since this dataset had many irrelevant images, we filtered them manually to create a dataset with a total of 10,238 images finally. And we call this dataset as Kaggle driver dataset. Since distracted driving has now become very common, so we believe that this dataset serves a beneficial purpose. But this dataset do have limitations. So we can observe the limitation in this slide for the Kaggle driver dataset. As you can observe that there is a consistency in the foreground or background scenes in the sample images. So this consistency persists in the entire Kaggle driver dataset, and that's why we conclude that this dataset is not sufficient for a thorough evaluation of object detection techniques. So, to overcome the limitation and test our techniques more thoroughly, we created another dataset called IITH DMU dataset. Basically, this IITH DMU dataset has images of people using phones in different backgrounds, lighting condition, angles, etc. IITH DMU has pictures of people in the office environment, market, or on hectic streets. These variations allow deep learning models to learn more effectively. IITH DMU stands for Indian Institute of Technology, Hyderabad, dataset on mobile usage. So you can observe variations in the foreground or background scenes in all these sample images from IITH DMU dataset. So these variations allow deep learning models to learn more effectively. After dataset creation, we move on to annotation task. Here, we decided which kind of annotation will best suit our requirement of detecting mobile. As this is object detection application, we required bounding box labels along with category labels. So for this, we use label IMG tool. As we discussed earlier, here our goal is not merely to check the presence of mobile. Instead of this, we want to detect whether the mobile is being used by the person. So that's why we evaluated on two annotation approaches. The first one is annotate mobile and hands separately. Here we use two bounding boxes, both for mobile and hand, and then try to find intersection between them. This approach is time consuming as we have to train two models, and besides of all this, the accuracy obtained by this approach is not greater than the another approach that we used called compound annotation approach. Here we use a single bounding box which contains both hand and mobile in it. And we finally used this approach for evaluating our dataset. After deciding on the annotation approach, that is sticking with the compound annotation approach, we move on to deciding what deep learning models we should use for evaluation of our datasets. Different deep learning models present a trade-off between predictive performance, model size, and latency. So choosing a good algorithm for a specific application is of vital importance. So to get a good head start to know what deep learning models we should use to evaluate the generality of our dataset, we searched out that these are some of the MAP scores results on COCO datasets. By comparing these models, we decided that we should use FRCNN, that is faster RCNN, and a single shot detection model, that is SSD model, in order to evaluate the validity of our dataset. So these are some of the four state-of-the-art deep learning models that we used for evaluating our dataset. Reason faster RCNN and SSD is used is being discussed previously. So why we select residual nets as our backbone? So we know that residual nets are deeper neural networks. So deeper the neural net, it may give good MAP score. But as it is deep, it will also lead to vanishing gradient problems. But in case of residual nets, we have skip connections. So they will cope up with that problem. So with the idea in mind that they may give us good MAP score, we choose residual nets as backbone. Why we choose FPN, that is feature pyramid neural network. So feature pyramid neural network or FPN is designed as a feature extractor that get merged up with the object detector. It can be used in those cases where we have to detect objects that have multiple scales. And as we discussed previously, mobile has varying sizes from feature phones to smartphones. So by keeping that concept of multi-scale features in mind, we selected FPN as a part of our selected deep learning models. So now we are going to discuss the experimental results on our two data sets. That is, one is the Kaggle driver data set and another one is the IITH DMU data set. So here in this slide we show the results of various selected models on Kaggle driver dataset. So here we can observe that SSD models are faster than faster RCNN for all the cases. So for latency critical situations, SSD models are preferred. SSD ResNet 50 with FPN as feature extractor is good in terms of both speed and accuracy. So here we can summarize that for Kaggle driver dataset, SSD provides a better trade-off between accuracy and speed than faster RCNN. So this slide shows the results of various selected models on IITH DMU dataset. Here we can observe that faster RCNN ResNet 101 backbone provides slightly higher AP score than ResNet 50 at the cost of higher latency, and faster RCNN has better accuracy as compared to other models. But the important thing to note out in this slide is that we are successful in getting a good MAP score for all in all the cases or in all the models for custom created dataset or for scratch created dataset. So this shows generalization aspect of our IITH DMU dataset. So these are some of the insights that we can conclude from all the above results that we just show. So SSD models are always faster than faster RCNN. For SSD, use of ResNet 50 with FPN leads to better AP than Inception v2. SSD ResNet 50 with FPN as feature extractor is good in terms of speed and accuracy. So at last we can summarize that SSD provides a better trade-off between accuracy and speed than faster RCNN. So this slide shows some of the images giving visualization of our results. As we can see in the last image, although the mobile and hands are close to each other, the person is not using the mobile. Or DNN models correctly predict that person is not using the mobile, and thus it's an example of true negative case. By observing all these images, we can summarize our results as follows. Our DNN models can correctly detect in both indoor and outdoor and in both office situation and a car situation. They can accurately identify mobile phones of different sizes, for example, feature phone and smartphones, and for varying degrees of overlap between the hand and the phone. Both the front and rear sides of mobile phones are correctly detected. For the misprediction results, you can refer our paper. In the aspect of future work, we are planning to include images from stereo camera and then perform depth estimation. This will allow us to improve the accuracy and also handle more difficult scenarios. These are some of the references. That's all from my side. Thanks a lot for listening.
Hi, and welcome to my talk about ambient air quality notifications for smart rooms. My name is Chitai Dang, and I'm from the University of Augsburg. The contributions of our paper are the results of a comparative study in which we investigated and compared 3 different types of unobtrusive ambient notifications for the air quality in a smart-equipped meeting room. We will also discuss the experiences of the participants and conclude with recommendations based on what we have learned. So, what's the problem that we addressed? A lot of us know the situation of longer-lasting meetings with many participants in a meeting room where doors and windows are closed. After a while, the air becomes stifling and uncomfortable. Modern buildings consider this circumstance already, as they have modern ventilation systems already built into the room. However, many existing buildings are old and larger rooms are often reused as meeting rooms for which they were not designed in the first place. They have no ventilation systems, but windows and doors. So, ventilation happens through opening windows and doors. So, when it is recommended or even required to ventilate a room, many studies showed that bad air quality, in particular with higher CO2 concentrations, that is carbon dioxide, have an impact on concentration capabilities of participants. Participants in a meeting are usually concentrated and they usually notice poor air quality when it's too late. In this work, we concentrate on CO2 as numerous studies have proved the scientific implications of the effects. With the increasingly widespread usage of smart home technology and high availability of low-priced commodity components, there are sensors to measure air quality, microcontrollers to process data, as well as means to signal or notify air quality state. Those smart home technologies offer great potential to support the intended ventilation methods of meeting rooms through notifications. But which kind of unobtrusive ambient notifications works best for a meeting scenario? Let's consider the scenario. Participants are usually concentrated. They listen to a speaker, a presentation, or to other participants. And they may also work individually on tasks. So the requirements on air quality notifications are that air quality notifications are not the first priority. They must not disrupt the meeting, and they should be perceivable and easily perceived. Hence, we chose 2 different kinds of unobtrusive ambient notifications, that is ambient light and the vibration of a smartwatch. The reason why we chose these types are ambient light is the most unobtrusive type, which benefits from peripheral attention, according to Hiroshi Ishii. The vibration of a smartwatch is unobtrusive and decent for a meeting scenario with multiple participants. We investigated the notification types in a smart-equipped meeting room, which you can see in the sketch at the right. It was a large meeting room that could accommodate up to 20 persons with 20 seats. There was a large table in the middle of the room and a large projection area on the front wall with a top-mounted shot roll projector. There was 1 door and 5 windows for ventilation. In terms of smart components, the room was managed by a Raspberry Pi 3, to which a CO2 sensor was connected to. We used an energy-efficient and precise infrared CO2 sensor from TFA, which you can see in the lower right picture. The Raspberry processed the sensor data and was responsible for managing the ambient notifications. Furthermore, we had 6 RGB LED stripes mounted next to each window, as you can see in the lower left picture. These LED stripes were controlled by ESP8266 microcontrollers, which received their commands from the Raspberry Pi. And finally, a Wi-Fi router connected the components over wireless connections. When we designed the study, our aim was to study a realistic meeting scenario. Meetings usually take place with at least two participants. This is important for the perception of the whole experience because being alone or not may have an influence on the perception of ambient light notifications. Therefore, we studied the perception with two participants in each session. The meeting scenario must also be controllable and repeatable as good as possible. To achieve this, we adopted the study design of Mann and colleagues and let participants perform an adequate cognitive load task that also occurs in typical meetings. Our design included a primary task in which participants performed the high cognitive load and a secondary task which addressed the peripheral attention. In the primary task, participants had to listen to a talk and answer questions during the talk, and in the secondary task, participants had to perceive ambient air notifications and report them instantly. Okay, let's have a look at the details of the primary task. The aim was to retrieve a high cognitive load of the participants during the whole session. Participants listened to a talk which was projected on the projection screen in front, as you can see in the picture. It was a TED talk from Michael Hübel in 2012 and lasted about 18 minutes. The speaker talked about the end of private ownerships of cars. During the talk, participants had to complete the quiz as good as possible. The questions of the quiz were displayed on a notebook in front of the participants. You can see an example of a question in the picture on the lower right. Overall, there were 29 questions spread over the whole talk, where the questions matched the course and content of the talk. Questions appeared at predefined times and disappeared after answered or if the next question appeared. So participants had to follow the talk to get the right answers. As a reward, participants were promised coffee and sweets for successfully completing the quiz. But basically, every participant was given a reward and was invited to talk about their study experiences while having the reward. The secondary task addressed the peripheral attention, that is, to perceive the ambient notifications which were conducted through ambient lights and smartwatch vibration. The color of the LED stripes were green and brightness was high in the neutral case, that is, when the air quality is good. We had three types of ambient notifications which we denoted as permanent, pulsing and smartwatch. In the permanent condition, the color of the LED stripes changed from green to red and stayed at red. In the pulsing condition, the color of the LED stripes changed from green to red and the brightness faded between light, dark and bright with a period of 3.5 seconds. We tuned the pulsing to slow pulsing in order to make the behavior reminiscent of breathing instead of an alarm character. The third condition, smartwatch, was based on the pulsing condition, but in addition to that, had the smartwatch vibrate once for 0.5 seconds. During the talk, all three notification types were presented to the participants in an interval of 5 minutes. The presentation sequence was counterbalanced and randomly distributed over 9 sessions. After 60 seconds, the LED stripes switched back to bright green color, the neutral case. Participants were instructed to click on a notification button on the notebook in front of them as soon as they noticed one of the notifications. You can see the button in the screenshot at the right. Furthermore, they had to indicate how motivated they were from 1 to 5 to open a window for ventilating the room. The notebook logged the response time and motivation for a later statistical analysis. This approach follows the experience sampling method to query participants' experience at the moment of the occurrence and in the immediate context of the scenario. The study was conducted with 18 participants. 7 of them were females, and all of them aged between 20 and 34 years. Most of them were university students and lab staff from the field of business informatics, computer science, primary school teaching, and journalism. All of them were right-handed and 11 were experienced with smartwatches. The participants were randomly assigned to 9 sessions. On arrival, participants were welcomed and had to sign a data protection form. Afterwards, they answered a questionnaire that retrieved demographic data and included a short version with 10 questions of the Big Five inventory to gather personality traits. Then participants were given a document to read, which introduced them into the study and provided descriptions of the study, the meeting room system, and the study procedure. Before starting the study, participants had to acknowledge that they understood everything. In all, during the whole study, interaction between participants and experimenter was kept as minimal as possible. Each session lasted between 40 and 60 minutes, depending on the post-study discussions about participants' experiences. Okay, let's discuss the results. During all sessions, the primary task succeeded in inducing cognitive load and focusing the attention of participants. Of 522 questions, 95% were recognized and answered, and of them, 92.5% were answered correctly. On average, each question took 8.24 seconds for an answer. That is, to read the question, think about it, choose the right answer, and submit the answer. We could also regularly observe emotional reactions of the participants. For example, laughter, when the speaker made funny statements. From this, we can conclude that the ambient lighting moved to the peripheral perception of participants. On the right, you can see the bar charts of the results of the secondary task. In terms of response times, the worst was the permanent condition with about 14 seconds. The fastest was the pulsing condition with 5.77 seconds. Even though the smartwatch condition was based on the pulsing condition, it was slower perceived than the pulsing condition, which may appear too high at the first glance. But we observed that even though participants knew that the smartwatch merely vibrates once, and there was no need to look at the smartwatch, more than 6 participants first looked at the smartwatch before they confirmed the notification. This was a natural reaction of the participants. A repeated measurement ANOVA revealed that there was a significant difference between the conditions. Pausing was perceived significantly faster than the permanent condition. We also asked participants to rate their motivation to open a window for ventilation. The highest ratings were given for the smartwatch condition, which may be because the smartwatch addressed them directly as a participant. However, as the median rating was 3, all the means are below 3, which indicates that the general motivations were rather restrained, even though some participants rated very motivated, that is 5, to open a window. Here, the statistical analysis did not reveal clearly significant differences. We also measured personality traits of the participants, that is, openness, conscientiousness, extraversion, agreeableness, and neuroticism. We conducted Pearson correlation tests across all dimensions with the motivation ratings, but could not find strong correlations. So, what we have learned was that in the smartwatch condition, the smartwatch seems to interfere with ambient light displays and may have induced confusion in that situation. Personality correlations with motivation to open a window may exist, but related variability may be too large, and a larger study is needed to explore related effects. In post-session discussions, participants told us that there was no punishment for not wanting to open a window, and they did not really experience bad air quality. That means they did not experience intrinsic motivation to open a window, for example, for healthier living. And they also did not experience extrinsic motivation. For example, getting a reward or preventing punishment. Some of the participants were to open a window. However, they felt that the quiz was of higher priority, and some expressed that they would be missing out the presentation if they would open a window. So, what can we conclude? At first, smart home and IoT technologies and the rapid development of the market is quite suitable for retrofitting conventional rooms and spaces. But in the design, we have to consider application scenarios and room usage. In our work, we presented this for a realistic meeting scenario. We investigated appropriate ambient notification types for room ventilation. In the current corona situation, ventilation of a room when it's necessary became much more important, and the same study would maybe produce different motivation ratings. Our statistical results show significant differences in the considered types, where parsing was perceived fastest through peripheral attention. Our recommendation is using parsing for effectively notifying bad air quality and having the smartwatch plus parsing as an alternative, or to address particular participants. Thank you for your attention.
Hello, my name is Parveen from STCN in Pisa, and I'm going to present integrating Alexa in a rule-based personalization platform paper today. Voice-based personal assistants like Alexa, Siri, or Google Home are highly popular nowadays since they provide people with natural connection to their online searches, music, IoT smart objects, alarms, and etc. One aspect that makes these voice assistants particularly interesting is the possibility of combining them with external services that they name a skill in Alexa or, for example, Action in Google Home, which are programmatic extensions that provide additional functionality towards a variety of actions ranging from sending routines, reminders, and notifications to controlling applicants and smart objects. However, with different users accessing different services and applications in a variety of scenarios, there is a need for users to be able to directly personalize the behavior of the applications they use according to their current needs and goals. Several platforms are available to support end user in specifying personalized behavior, for example, the IFTTT. But they have some limitation. For example, they just support one trigger and one action. So, the opportunities offered by integrating this vocal personal assistant like Alexa with a platform that provides programmable and personalized support seems worth investigating. One challenge in this integration is that not all the languages are supported by vocal assistants. For example, Alexa just supports 7 languages or Google just 13 languages. And not all the smart devices are supported by them. For example, the Philips Hue starter kit, Fire TV, camera security system, and etc. They are supported by Alexa. But for example, the Great Luminaire, it's not supported by Alexa. So we developed a solution that integrates Alexa within the personalization platform, enabling users to specify the joint behavior of various devices applicants, also providing support for playing vocal notification and reminder in any languages, including those that are not currently supported by Alexa. To highlight our goal and to show the possibility of the integrated personalization platform, we describe this scenario. Mihai is a Romanian health specialist who lives in Austria. He has a personalized system in his house that allows setting up various automation used by him and his family. For example, a rule to remember him about his son's football matches schedule at school, or a rule to activate a relaxing scene exploring a luminary in the living room when it's about the time to go to bed. Furthermore, he has an Echo.Alexa smart speaker which has been integrated into the system to provide him with the possibility to relieve his emotional status. For example, he said on board, And it's activate such an inviting him to start an activity like let's play your favorite game, or automatically carrying out some actions, for example, turn on a light color to improve his mood. Mihai has a father, Adrian, who is a 75 years old Romanian man who lives alone in a flat in a big city in Romania. He suffers from diabetes, which has to manage it by following a proper diet, doing a regular physical exercise, as well as taking some pills and medicines. Mihai thinks that this system could be very useful for his father also, to better organize his daily routine. He would easily create some personalized rules for Adrian since he knows well his father, activities, and problems. So he started to investigate the possibility to use the platform to remotely support his father. However, at some point, he found out that Alexa does not support the Romanian language, and he was very disappointed for this, since he thought that vocal communication can be immediate and effective in communicating messages to his father. When some problem occurred, for example, when he forgot to take his medicine. However, after a while, he found out that a new version of the personalization platform was able to render voice messages even for the languages that are not supported by Alexa, and it was a great news. Because in this way, he can provide his father with relevant notification reminders in Romania. So he decided to deploy the system in his father's home and started to create various rules for him by programming reminders rendered through Alexa. In this way, the system can, for example, remind Adrian about the medication that he must take in appropriate time and condition, but also properly support him in managing diets and physical activities according to relevant contextual factors. For example, depending on the outside weather condition, it can invite Adrian to have a walk outside. When Adrian tried the system, was so happy to have a tool that allows him to better manage his life. Thus, this system improves Adrian's self-care and supports a more independent lifestyle. And more importantly, it enables Mihai to structure and support his father's schedule, tasks, and reminders when he cannot be there in person. This work has been carried out in the context of AAL Petal European project, which aims to increase the elderly autonomy and assist them in carrying out activities of daily living. For this purpose, we developed the Tareme platform to enable the people without programming knowledge, like primary caregivers, but even elderly people that having some familiarity with technology, to control the objects and devices in the home setting. The main platform composed from a tailoring environment, the rule manager, and the context manager. The tailoring environment supports specifying personalization rules according to the trigger action format and helps to overcome issues existing in the environment having the similar goal, like the IFTTT, by clearly distinguishing events and conditions, and also supporting the composition of the multiple triggers and actions that can occur in the considered context. They are composed of 3 dimensions, which is user, environment, and technology. And they can be composed through and, or, and not operators. The actions are the intended effects to achieve when a trigger is verified. And they are classified in terms of reminders, alarms, appliance state changes, and recently we add the Amazon services also. So when the user activates a rule for its execution, the tailoring environment sends it to the rule manager, which in turn also it asks the context manager to be notified when the corresponding triggers are verified. So the context manager is composed of the server and multiple context delegates that communicate with the associated sensors and objects to be informed when the state of some objects change. Such a platform was applied in the first round of trial of this Petal project, which we had the 6th trial with the 6 users in Italy, Romania, and Austria by using a set of off-the-shelf sensors, smart objects, and devices. Based on our goal and motivation, we decided to add Alexa for the second round of trial, but we encountered some issues, like Alexa does not support the Romanian language, and the great luminar lamp that has been used for high visual demands and create an activating or calming room ambient with different light sense was not activated through Alexa. So, for supporting our idea, we developed this architecture. As soon as events are generated by the various triggers contained in the user home, they are sent to the context server, which stores them and updates accordingly to its repository. When a trigger contained in a rule is verified, the context server notifies the rule manager, which then sends the actions to the OpenHub Rule Manager add-on, able to interpret and apply them. If the action involves an appliance, like a light, the Rule Manager add-on can exploit the OpenHub to interact with such lights. But if the action specifies a reminder or an alarm that should be vocally rendered, it acts differently, depending on the languages of the messages. That I will explain it in the detail in the next slide. So, the integration of the Alexa to the platform has given the possibility to extend the set of available triggers and actions. For the triggers, in the user-related contextual dimension, we added the features allowing users to vocally provide their current emotional state, like happy, angry, fun, bored, worried, sad, and etc. And even to provide the vocal comments, such as turn on relaxing scene in the living room. So it concerns the devices that are not supported currently by Alexa. Regarding the actions, we have introduced support for activating the available Alexa services like news, music, or for weather forecast skill when a rule is triggered, and the possibility to communicate the reminders or alarms through the vocal channels. This makes it possible to execute rules such as, for example, if the user has not taken a medicine between 8 and 9 in the morning, then Alexa speaker should remind them by saying, remember to take your pill, which is important for your health, for example. But how it works? If the language of the text is supported by Alexa, it exploits the OpenHub binding for Amazon Echo device and play it. This binding is able to exploit the Echo device as a text-to-speech service by sending a request containing the text of the alarm or the reminder defined in the received action, so that the smart speaker can vocally render it. If the message is written in another languages which is not supported, it's not possible to exploit the Amazon Echo binding because the message will be synthesized in a wrong manner. So in this case, first, the platform gets the user-defined text from the action, then it generates the corresponding audio file by exploiting the Google Cloud Translation API and store it in the platform. This file will then be played through the vocal assistant by exploiting the speech synthesis markup languages tag. The platform sends the action to the OpenHub add-on, which recognizes that the language is not supported by Alexa, and launch the petal notification skill so that the message can be automatically played. Here is some example of how to, for example, make rules containing Alexa as a trigger or as an action. For example, if the user is feeling bored, do play the news services. That we have added some services like news, weather, and petal assistant, which can ask the user how he feels, or even user can activate the devices that are not supported by Alexa. For example, turn on the grid luminar, turn on the relaxing scene. So how the skill works? We define the skill logic as an AWS Lambda function in which first we identify the user who is interacting with the system, with the Echo device, by allocating an ID to each user in the system. Next, a request will be sent to the rule manager to get the ID of vocal messages related to this user. Later, a request for each retrieved ID will be sent to receive the corresponding audio file. As soon as an audio file is played, the user has the possibility to listen to the message again or delete the message from the server. The Amazon Alexa skills are in general passive. Users should explicitly issue voice commands. In this case, Alexa, please open Petal notification, that enables them to check their messages. But for those who live with a disability, illness, or aging, it could be difficult to remember or sometimes to call the skill. For this reason, in our system, a vocal notification can be an action contained in a rule whose triggers are activated when a specific event occurs in the user contents in this case. The notification is played automatically without any user explicitly asking for it. So, as a conclusion, we have reported our initial experience in integrating a widely used vocal assistant Alexa in a personalization platform that allows end users without programming experience to directly indicate how they want to exploit the variety of sensors and connected objects that are increasingly available to them. So the goal was to better exploit the immediate and natural way of interaction supported through such devices by connecting it with events that occur in their daily life and can be detected with the support of IoT technology. The initial target user of this integrated platform are older adults living autonomously in their home, and their formal or informal caregivers who knows well their habits and abilities and can in this way create the rules defining the most suitable automation for their daily life. We have discussed an initial set of possibilities obtained through such integration, which extend the traditional way of use the vocal assistant. Besides, we have also indicated a technical solution to address one further limitation in Alexa concerning the languages currently supported. Such a solution allows the platform to generate vocal messages associated with some triggers in the language not supported by Alexa, so lowering the associated language barrier generated by such a limitation. Future work will be dedicated to gathering the empirical feedbacks on the integrated platform by the target user. So for this purpose, we have planned several trials in the various European countries in which the personalization platform together with the associated sensors and the connected objects will be deployed in the elderly's home. This was my presentation. Thank you so much for your attention. And if there is any question, please do not hesitate to contact us by this email. Thank you so much.
Hello, my name is Andreas Seiderer and I will present our paper Development of a Privacy by Design Speech Assistant Providing Nutrient Information for German Seniors. Speech assistants with natural language provide the easiest interaction with a computer system. Especially elderly can profit from easy-to-use systems who may use them for health-related tasks like receiving nutrition information. Nevertheless, there are several problems which occur with current commercial speech assistants. Current assistants do nearly all processing steps on the provider's servers. As a first step, usually raw audio of the voice is sent to them. It now depends on the provider what is done with the data. For example, it is known that several companies partly manually transcribe audio data with their employees. This is especially a problem if the audio data was recorded without knowledge of the users due to problems with the keyword detection. Thus, for privacy-sensitive tasks, this might not be an acceptable option to share data at all. Additionally, it is still even in developed countries not the case that devices always have a stable internet connection. Especially rural areas where often an older population lives are affected. Without internet connection, most speech assistants are not operational. Finally, speech assistants are often not explicitly adapted to the needs of seniors, which can cause a lower user experience. With our work, we want to present a solution to these problems. We developed an offline usable, open source speech assistant. We selected the task of nutrition information retrieval for the system. Additionally, we conducted a small workshop with 2 seniors to identify special requirements in regard to speech assistance for elderly persons. Our system was designed to follow the principle of privacy by design. The basic idea of privacy by design is to integrate privacy into networked systems and technologies by default. It should never be required by users to actively change settings to have a privacy-respecting system. Thus, privacy should not be integrated afterwards, but already considered in the system from the beginning. This is also the case with our developed system. However, we used an enforced version of the privacy by design principle, since we didn't accept closed source software for any component, including machine learning models. Additionally, an internet connection should not be required at all, or only temporarily to download the required database. For our speech assistant, we chose the task of receiving nutrition information of a packaged foodstuff. Although most of the information is already included on the packages, in many cases it is hard to read. Especially for seniors, it might be unreadable without magnifying reading help and good light conditions. The picture on the slide stems from a fish can. This is such an example where also the contrast is very poor and thus not only for seniors hard to read. Currently in Germany there is no law to include ratings of the healthiness of foodstuff on packages. Nevertheless, some manufacturers provide such information. Thus this problem should also be coped by our system, since such information makes it more easy to detect unhealthy foodstuff. The process of receiving nutrition information from our speech assistant first starts by scanning the barcode of a packaged foodstuff with a camera. Next, the system receives the information of the foodstuff from the Open Food Facts database by using the barcode. This database is completely open and all data is added by its community. With this data, it is possible to determine the Nutri-score, which is a rating of the healthiness from A to E, where A is healthy and E is unhealthy. In some countries, this information is already included on the foodstuff packages. Additionally, we provide information about whether the sugar and fat amount of the foodstuff is low, moderate, or high. In the following, an overview of the components of the speech assistant is given. First, there is a trigger which enables and disables the automatic speech recognition by using a button or a keyword spotter. The speech recognizer receives audio data from the microphone, which it transcribes into text. The text is processed by the natural language understanding so that the system can more easily process it further. The dialog manager uses these results to determine the actions of the system. It usually also keeps track of already provided information from the user. If the intent of the user can be handled by the system, it generates a response, including the requested information with the natural language generator. In other cases, natural language generation can be used to ask appropriate questions or tell the user that the system could not understand the input. Finally, the generated text is output via audio by using text-to-speech synthesis. Commercial services usually run all components on their servers except for the trigger. It should be noted that the highlighted components, are also part of textual chatbots. On this slide you see several frameworks of open source speech assistants. We selected only frameworks which support non-English languages. The used offline capable speech recognition and text-to-speech components are shown. In general, such frameworks can simplify the development of a speech assistant. Nevertheless, in the following it will be explained why we chose an own combination of components. First of all, some of these frameworks are intended to be used on very limited hardware, like a Raspberry Pi 3 with only 1 GB of RAM. This is usually already not enough memory for complex offline speech recognition and text-to-speech generation. For speech recognition, only Mozilla's DeepSpeech and Kaldi use modern deep neural networks, which are usually superior to traditional methods. None of the frameworks uses deep neural networks for text-to-speech, as most options are still experimental. Another problem was that at the beginning of the development of our speech assistant, there was no German model for deep speech available, but one model for Kaldi. LinSTT does not provide a German model. The Microsoft Speech Assistant framework does not integrate Kaldi out of the box, so that an own Kaldi instance would have to be set up in any case. Thus, we chose to use an own software combination, which also allows to be more flexible with the selection of software components. This slide shows an overview of the communication between the components of our speech assistant. On a local server, following components were deployed. For the speech recognition, we integrated Kaldi. For natural language understanding, Dialog Manager, and natural language generation, the Razor framework was used. It could access a local copy of the Open Food Facts database. The speech synthesis was conducted by MaryTTS. A graphical user interface was provided by using a web server which hosted a website. The website with the GUI could be accessed from another device like a tablet PC, which should provide a camera for the barcode reader, microphone for spoken user input, and loudspeaker for spoken system output. The GUI could be controlled by mouse or touch. Kaldi was used with a German model which recognizes 400,000 German words. Depending on the system and sentence length, it provides good latencies. With a desktop PC, it usually took 3 seconds to transcribe short sentences. The Razor framework is a chatbot framework. For natural language processing, SPACY can be applied, which was used with a German model. The natural language understanding detects the intents of users, like requesting a specific nutrient information, and fills in entities like sugar or fat. In our case, 43 German sentences in total were enough to train a model that could detect all required intents and entities. However, for more complex systems, additional examples would be required. After recognizing the intents and receiving the entities, actions are called to generate template-based text responses. Required data is requested by using the barcode from the local Open Food Facts database. The database contained about 1,111,000 foodstuffs. Eventually, the data was interpreted. MaryTTS with a German model was used as the text-to-speech engine. In our case, it provided reasonable, understandable spoken output. Nevertheless, proper names can cause problems. A short demonstration of the system is given in the following screen capture. It should be noted that in this case the barcode recognition was already carried out. The video provides the original latencies, including the button presses of the user, and was not cut in between.
Was möchtest du über Orange direkt gepresst wissen?
Wie lautet der Nutri-Score?
Die Note ist C. Möchtest du noch eine Information?
Wie viel Zucker ist im Lebensmittel enthalten?
Es sind 9 Gramm Zucker in 100 Gramm enthalten. Verhältnismäßig ist das sehr viel. Kann ich dir noch weiterhelfen?
Wie viel Fett enthält das Nahrungsmittel?
Pro 100 Gramm sind 0,2 Gramm Fett enthalten. Verhältnismäßig ist es wenig. Möchtest du noch eine Information?
Our speech assistant was also presented to 2 seniors in a workshop. This workshop was conducted to gain insights into special requirements needed by elderly persons in regard to speech assistance. We acquired a senior couple with an age of about 60 to 70. The workshop was conducted at their home with the prototype. The seniors already had experience with smart home technologies. Nevertheless, it was limited to automation and visualization. For the client hardware we used a Surface 4 Pro and for the server a small desktop PC and Linux operating system. The workshop was conducted by one researcher who explained the workshop procedure, demonstrated the prototype, and conducted a semi-structured interview with the seniors. The researcher wrote down notes during the workshop. After the demonstration of the prototype by the researcher, the seniors were allowed to test the system on their own. The semi-structured interview included noticed problems and possible extensions of the prototype. We were also interested in the location where the seniors would like to use such a speech assistant. Additionally, they were asked whether they would accept to use a smart display or smartphone. As privacy was of high importance during the development of the system, we asked the seniors about privacy concerns. Furthermore, the relevance of the nutrition data for the elderly persons was asked. In the following, some results of the workshop will be shortly discussed. One of the problems that occurred when the seniors tested the system was related to the speech recognition. The word Nutri-Score was not included in the dictionary. This problem was already noticed during the implementation. Nevertheless, the speech recognition model cannot easily be adapted without several training data. Thus, we circumvented this problem by allowing to ask about the healthiness of a foodstuff. Additionally, not correctly recognized words could be corrected in the text input. In general, the interaction with the system was easy for the seniors. The text on the display was readable by them. Most of the words were correctly recognized by the speech recognition, and the text-to-speech engine was most of the time understandable. The seniors found the system helpful since they usually required a reading help to read the nutrient information on the packagings. Usually they would be most interested in using the speech assistant in their kitchen. Also, the interpretation of the healthiness and of the sugar and fat amount were appreciated by them. The seniors were aware of privacy risks of speech assistants and valued that our prototype doesn't share any data. Thus, such a system would be accepted even if very privacy-sensitive health information would be handled by it. Asked about possible extensions, the seniors would like to request additional nutrient information like contained vitamins. However, such information is not included in the Open Food Facts database, and additional special databases would be required. Another extension they could think of was a combination with inventory management, so they could, for example, ask the system about foodstuff whose best before date is close to the current date. In general, we could show that it is currently possible to implement an offline, open source and privacy respecting speech assistant for the German language. Additionally, no high-end servers are required if the tasks are constrained. Nevertheless, we found that at this time there are only few solutions for the speech recognition and text-to-speech, which is especially true for non-English languages. Our prototype was also well accepted in the first workshop with 2 seniors for the task of receiving nutrition information. However, there are several possibilities for improvements on the technical side. For example, a German language model can now be found for Mozilla's Deep Speech, which might have benefits but would require comparison for specific tasks. Furthermore, for text-to-speech, there are already modern deep neural networks-based solutions available for the English language, which can provide more natural spoken output. It might be possible to find models for the German language in the near future. Additionally, more complex information related to nutrition could be provided by the speech assistant. In the future, also the extensions mentioned by the seniors during the workshop could be considered to make the system more useful. Further investigations with more elderly persons are required to evaluate and improve this first prototype according to the requirements of seniors, since this target group is quite heterogeneous due to possible age-related illnesses. As a long-term goal, a speech assistant with at least for some tasks comparable functionality to commercial systems would be beneficial. This would allow privacy-respecting alternatives and could make speech assistants available for more people. Thank you for your attention.